So welcome all. Hello. Hello. Welcome all the participants. Hello. Hello. Cool. Hello. Hello. So we welcome all the participants. So all the participants are welcome. So today our resource person, Dr. S.V. Saravanan sir, who is going to handle the session, first session as well as the second session. The topic of role of startup in India, EV ecosystems. See, our respectable and beloved resource person having more than 30 years of experience, and he worked as a principal more than 16 plus years, and he was a position of as a professor more than 20 years, and he guided more than 10 scholars, and currently they are guiding around 7 scholars, and they got the 62 number of international journal, and he published articles, research articles or review article in international level 62 numbers and national level 8 numbers, and they contributed more in research in IC engines in the mainly in German field. He attended and many international as well as national conferences. He submitted a paper, research paper in 10 number of papers in international conference and 17 number, more than 17 numbers in national conferences. He is specialized in internal combustion engine and management. Most of his research work in the field of IC engine and its emission, energy and energy conversion, environmental pollution, and entrepreneurship, management, and as well as interdisciplinary, as well as multidisciplinary research work. He published around 7 books, textbooks, which is give credit to his credit, and he has the editorial member and reviewer for many international as well as national journal. He is a life member of
कर दे रहे हैं 100%, ठीक है? थ्री छोड़ करके कहीं भी कुछ पेपर बचा हुआ है कि नहीं बचा हुआ है? अकाउंट्स वाला आया है?
He attended many seminars, conferences, and international conferences in worldwide, in as well as all India level. And he is an expert in NAC, IQAC, and National Board of Accreditation. And he got the award of Best Faculty Award, Distinguished Alumnus Award, Lifetime Achievement Award, Best Engineering College Principal Award, and Kalvi Kalaimani Mamani Award, Appreciation Award, and Best Paper Award, Best Project Award, and so many things we got. Yeah, a valuable and respectable resource person we have today. He's going to deliver the lecture on the topic of role of going to take the special topic. It should be very useful to participant as well as for me also. The topic is role of startup in India's EV ecosystem. So we welcome sir, Dr. Saravanan sir. We welcome on behalf of our college as well as the participant. Welcome sir once again.
Thank you, Dr. Vijay sir, Professor of Mechanical Department and also the co-coordinator of this ATAL FDP online program. Very good evening to all, for all the participants. As a coordinator of this FDP program, it is my duty to let you know a small change in the schedule today. Two of our expert members on domestic emergency, they are unable to present their topic. So as a coordinator, I am presenting those two topics. We welcome you for the session 7, 30/1/2024 from 6 p.m. to 7:30 p.m. The session title is The Role of Startups in India's EV Ecosystem. Before going to the ecosystem, EV ecosystem, why these startups are needed? What is the role of these startups? As you all know very well, in India and also throughout the world, we have millions IC engines that run in the roads to carry out the needs of the transportation from one place to another place, both for the human being transportation and also the material commodity transportation. Now, because of the fossil fuel depletion and the introduction of this electric vehicle, we are in need of an EV ecosystem to cater the needs of new EV vehicle that is going to be replace the conventional IC engines. For that, immediately we may not have the mega setup to cater the needs not only for charging but also the ecosystem of the EV system. For that purpose, we do have the startups. Initially, before going to have the permanent one, the startups are initiated to have the better EV ecosystem. For that purpose, this session 7 is more important, that what are all the roles of various startups in India and how it is going to help the EV ecosystem in detail. India is shifting towards the electric mobility, as you all know very well. Startups are in key innovation and affordability and infrastructure. Government and environmental concerns are driving the EV adoption. We all know very well, we are shifting from conventional fossil fuels IC engines to electric vehicles. These electrical vehicles badly in need of the electrical energy to charge it. Hence, to initiate the process, more startups are needed that hold very good innovation and affordability, and also the very good infrastructures are needed for the startup. What are all the main forces driving this EV? We should know. The government, the legislative body, and the environmental concerns are the main driving force for this EV adoption. Why the EVs matter? EV stands for electric vehicles, you all know very well. It will have the reduced carbon emissions. It will support and it will help the greener environment so that the 5 basic elements will not disturb by the transportation concept. lower dependence of fossil fuels because we run on the electrical energy only. It is a cost effective in the long run. Government incentives and policies are helping for these EVs. The role of startups in India for EV ecosystem. India's electric vehicle ecosystem is undergoing a rapid transformation driven by a combination of government policies, consumer demand, and technological advancements. Startups play a crucial role in accelerating this shift by introducing the innovative solutions, addressing the infrastructure gaps, and making the EV more accessible. We all discussing the major shift from the conventional IC engines to the e-vehicles. E-vehicles are in need of the electrical energy charging systems. Those charging systems are to be available in the highways and as well as in the sub roads so that we will not face any difficulty for the charging purpose. Again, it should come under the various government policies, consumer demand, and technological advancements. So these startup policy play a crucial role in accelerating this shift by introducing the various innovative solutions, and various gaps has to be addressed in terms of infrastructure, and making the EVs more accessible for the large number of users. Initially, there will be only less number of EV users. When days goes up, then the entire shift will happen from conventional IC engines to e-vehicles. Then it should be more accessible. The role of startups in India have the EV industry. These startups drives have 7 basic elements. Number 1, innovation and R&D, affordable EV manufacturing, charging infrastructure, battery swapping and recycling, fleet electrification, government collaboration, investment and job creation. In this broad 7 categories, we are going to see the what are all the startup for the EV ecosystem. Here is how startups are shaping the India's EV landscape. First, in the driving innovation and technology development, startups are pioneering advancements in EV technologies, including battery innovation, solutions, and software-driven vehicle management system. Any new technology comes, it has to driven through the innovation, and the development has to take place. Companies like ATAL Energy, Ola Electric, and Log9 Materials are developing cutting-edge lithium-ion and fast-charging battery technologies, making EVs more efficient and affordable. Now we are going to see what are all the various innovations and R&D. New battery technologies like lithium-ion, solid-state, and aluminum air, artificial intelligence-driven smart EVs for efficiency and safety, lightweight materials, key players, the Ather Energy, Ultraviolet, and Log9, all the various vehicle photographs where the innovation and R&D is taking place. Here is how startups are shaping India's EV landscape, expanding EV charging infrastructure. You could see in the diagram, these are all the very smart EV charging system. one of the biggest challenges in EV adoption is the lack of widespread of charging infrastructures, because to install and to have the infrastructure, we are in need of huge money and also the interest from the common public. Since it is a new technology, people now having the difficulties that how long the EV will serve our purpose. Why can't I continue with this old IC engine vehicle? Why I should change the IC engine driven vehicle? Because I have invested a lot, say for an ordinary small family, middle level family, they are investing up to 5 lakhs amount for a car. Since we are the introduction of this EV technology, they no need to change the car from the old technology to new technology. And also because of the depreciation, the IC engine driven, the automobile will go for very less price after 5 years depreciation or 10 years depreciation. So the customer is in the mindset of that, why I should invest huge money to have the e-vehicle. That's why government is legislating the various norms. Bharat stage 1 norms, Bharat stage 2 norms, stage 3, stage 4, stage 5 and stage 6. Various norms are introduced in stage by stage level, so that the common public will change from old technology to new technology. For the simple reason, the main point is to reduce the automotive emissions. Emission, basically the fuel used in the IC engine is hydrocarbon. Basically, the hydrogen and carbon atoms are there. As we all know very well, the hydrogen is completely burning in nature, and carbon, even after burning, it will exist. So these problems has to be addressed. Then only the environmental degradation will be taken care by us. Without taking care of the environmental, if we continuously using the IC engine, what will happen means the NOx, SOx, everything will, nitrogen oxide emissions, sulfur oxide emissions will disturb the environment, so that the so-called fresh atmospheric air which is used for the breathing purpose of human being is getting disturbed or getting corrected or getting its own originality, so that human beings are getting affected. Startups like Charge Zone, Static Q, and Bolt and Building Smart, affordable and widespread charging networks, making EV ownership and more convenient and practical. Some of the leveraging IoT and AI to optimize the charging station usage and to reduce the downtime. Whenever and wherever new technology has been introduced, people will not accept immediately. But once days goes faster, people like to attract the new technology and they will switch over from technology to the new technology. Because in India, like countries, the adaptability is the main problem, and also the financial is the other side of the coin. So having that in mind, this expanding EV charging infrastructure plays a vital role from the paradigm shift from the conventional IC engine to the new e-vehicles. Charging infrastructure developments, which includes the lack of widespread charging stations. Nowadays, we don't have more number of charging stations. Startups building fast charging and home charges and battery swapping. And yesterday also, a lot of queries has been raised by our beloved participants. Is it safe home charging? Is it convenient to do home charging? Will the home charging will be more fast, or shall I go for the charging purpose only for the charging station? A lot of questions has been asked in this past 3 days deliberations. Various experts has answered these questions that home charging is possible, home charging is safe, but to some extent, the proper ampere usage and current usage characteristics of the equipment we have to use. For example, the 5 watts electrical wire, we cannot use the same for 15 watts charging. What will happen? once it is repeatedly using, it's get heated and its conduit, it will disturb the charger, there is a chance of electric accident. So like that, various things have been addressed in the past 3 days. In charging infrastructure development also, it is very, very important. The key players are the charging plus zone and static bolt.earth. These are all the various players and now in the market is contributing for the EV charging stations. Here is how startups are shaping the EV landscape continued. The affordable, third one is the affordable and sustainable mobility solutions. It's normally people used to say that technically feasible and economically viable. The startups are focusing on providing an affordable electric two-wheelers, three-wheelers, and commercial fleets. Companies like Yellow and Bounce Infinity and Ampere Electric are making electrical mobility access through shared EV services and cost-effective personal EVs. These solutions are particularly impactful in reducing urban congestion and pollution. Yesterday, we also discussed one important point that what are all the use of hybrid vehicles. Hybrid vehicles can run in city limits in battery for less pollution or minimal pollution, and outer the city limits, they can be operated through the conventional IC engines. And also, the thing is, instead of polluting here, the battery also, while charging and decharging, it will degrade the environmental quality. Affordable EV manufacturing, cost-effective EV production for Indian roads, growth in 2 watts, 3 watt and electric cars. Key players again, Revolt Motors, Vola Electric and Yellow Motors. Coming here, the vehicle manufacturing cost. In 2000 compared to 2000, before 2018 and after 2018, at present that is 2025. See the vehicle assembly, combustion drivetrain and combustion engine, electric drivetrain, motor and electronics and battery pack. So again, this is in the conventional and 200-mile operation and 250-mile operation. It's fully electrical. This is plug-in hybrid, that is 40-mile and 60-mile in 2025. It is being compared with the 2018. Battery swapping and energy storage solutions. Battery swapping technology is gaining a traction as an alternative to conventional charging. Startups like Sun Mobility and Battery Smart are the pioneering battery as a service. It's called, we call it as BAS models, allowing users to swap depleted batteries for fully charged one within minutes, addressing the range anxiety and reducing vehicle downtime. This swap station, this diagram gives us the enhancing a depleted battery with fully charged battery. You can see here charging and discharging. This is under the electrical grid. This is fully charged batteries. This is the swap station. Now we are going to see the battery swapping and recycling technology. Swapping reduces charging time and enhances convenience. Recycling ensures stability and battery waste management. Again, these two are the key players in the market, Sun Mobility and Log9 Materials. Sustainability, supply chain and recycling. Startups are also focusing on the sustainable battery production and recycling. Companies like Lagom Cleantech and Atrio Recycling are working on extracting the valuable materials from used batteries, reducing dependency on imported raw materials and minimizing the environmental impact. The problem is we are not doing the safe disposal for the battery. Battery, what it will have? It have a battery console. It will have acid. anode, cathode, and separation plate. So these used batteries have to be disposed in the safe manner. Then only the environmental degradation will not take place. So all these things have to be addressed. Coming here, the diagram, lithium-ion battery supply chain. You can start with the mine and refine the cathode active material, cell and battery pack, application, and again the reuse and recycle. The 3R, reuse, recycle, and regeneration, are very, very important. It is the need of the hour so that we can save our environment. If environment gets affected, it will affect the clean air condition. That's why clean air policy also evolved in the worldwide. And it is also discussed in the various conventions and symposiums and conferences. And carbon contribution and carbon content, how the companies are, the countries are contributed for the less degradation of the environment, also is the school of thought here. Coming to the fleet electrification and the last mile connectivity, EV fleets for e-commerce, logistics and ride hailing, low costs and reduced pollutions. Again, the key players in the market are the Blue Smart, that is for cab purpose, and GP Electric, it is for delivery bikes. The government collaborations and policy advocacy. Many startups are actively engaging with policy makers to shape the EV-friendly regulations and incentives. By working with government bodies, they help design schemes that promote local manufacturing, innovation, and expansion of EV infrastructure. These are all the various government policies which will advocate the various non-governmental agencies and also private agencies to collaborate with the government to have the real world application and the real world life for the government policies. Now, startups benefit from the FAME 2 and PLI schemes, that is partnering with the policy makers for the infrastructure growth. Example, government-backed charging networks and subsidy programs. Government is also taking keen interest and also try to give wide publicity for the industry people and also the academia network and also for the common public, why this EV is more important and what are all the various, through MSCC also, various one-day programs, one-week programs and month-long programs are being conducted. EV charging station, EV methodology, EV techniques, like that, so many things are going to spread the various government policies and to advocate the same and to have the various collaboration from the industry's person to the common public view. These are all the various initiatives taken by the government. Now coming to the job creation and economic growth. See, any new concept comes, earlier it will not have any welcome note from the common public. Once it's gained momentum, once it start giving the income for the administrator or for the owner of the company, it will gain and more attraction and more momentum for the technocrats or the skilled laborers, semi-skilled laborers and unskilled laborers, and also for the common publics. Here, the EV startup ecosystem is generating employment across the various sectors, including the R&D, manufacturing, software development, and after-sales service. By fostering the skill development and investment in green technology, startups are contributing to India long-term economic growth. You can see the employment across the various sectors, as I already told, the industry, academia, and common public, and also the skilled people, semi-skilled people, unskilled people. The any new technology comes, R&D attracts a lot because the purpose of R&D is to minimize the cost and maximize the usage, and also the size has to be less. Now the world moves to the nano down size. The R&D has to concentrate on the battery size and battery capacities. Earlier, if you want to have the more capacity battery, naturally the battery size will be huge. Now, in the recent past days, the batteries are very, very minimum with huge capacity because of the R&D's contribution. And manufacturing also playing a vital role. Now, majority of the manufacturing layouts has been replaced by the automated manufacturing unit. Thereby, lot of workers are getting affected because of the automated manufacturing layout. The thing is, battery like environmental degradation, environmental disturbed area, we can employ even to the future highly expected demand like robots also can be employed to have very good manufacturing in the battery sector. Software development and after sale service also very much important because nowadays earlier we could not find any chip in the automobile, either in the car or in the big fleet. Now 50% or 25 to 50% of the conventional mechanical systems are replaced by the very, very small Silicon Valley product, the so-called chips. All these chips are operated by the software. So the software development also gaining momentum day by day because of the EV introduction. Again, coming to the after sale service, once an e-vehicle has been serviced, then we have to sold out, we have to do service for the until the disposal of the e-vehicle. These after sale service has to be taken care by the technical service personnel and also the so-called skilled service persons, semi-skilled service persons and unskilled service persons. Again, this area also getting momentum because of the EV introduction. By fostering the skill development, investment in green technology, see the green technology, a word we often hear in the recent past is that any technology now we are introduced is to it should be sustainable in nature. It should contribute for the green environment. Otherwise, again the environmental degradation will take place. Finally, it will affect the day-to-day life of the human being. So these startups now contributing for India's, now it is in very less economic growth. When the years to come in future, it will have very good long-term economic growth so that we can find rarely the IC engines or we can see only in the so-called science exhibitions and museums the IC engines because everything will be replaced by the e-vehicles. And also now e-vehicle charging is the major problem. We are now concentrating on the researchers are concentrating in the e-vehicle charging with the renewable power so that again we are not depend upon the conventional electric power, namely the wind energy and the solar energy. Wind powered e-vehicle charging stations, solar powered charging stations are gaining momentum at this juncture. These are all the various research points we should keep it in mind under this category. Coming to the investment and job creation, global and domestic investors fueling India's EV growth, job creation and manufacturing, engineering and software. Various examples in the market are the Ola Electric's $500 million investment in the battery R&D. Ola has invested this huge money is for the R&D purpose only. Now coming here for the various challenges faced by the startups in EV ecosystem, initial investment is very, very high. Also, the e-vehicle cost also initially it is very, very high. And this startup infrastructure is having the limited charging infrastructure because at a time we can put one or two only. We cannot have the multiple charging station because again initial investment cost is more for the first attempt. Battery supply chain dependencies are very much important. Consumer adoption is very, very important. Yes, I told already, consumer will not have the tendency to adopt the new technology, the new vehicle. Why? Because means we all know in the management concept is that AIDA principle, AIDA. Any product, including the EV, it should follow the AIDA. It should follow the product life cycle. What is AIDA principle? The e-vehicle should be attract in nature. and e-vehicle should have create and kindle an interest among the consumer. That is the second letter I. First one, AIDA is number one. A is attractive. I, it should create and purchase interest. And D, it should create a desire among the customers to purchase e-vehicles. If these three things satisfies together one by one or concurrently, finally the customer will land up with the buying action. That is the last letter A. This is the AIDA principle in the market survey or market strategy. So the e-vehicle should have attractive, should create an interest, should have a desire to purchase. Finally, the customer will land up with the buying process or buying action. All these things have to be taken in mind while designing the e-vehicle and in the R&D stage itself, so that the resale value also has to be keep it in mind, because every year depreciation will take place. Conventional IC engine also, if you purchase a vehicle, new vehicle for 1 lakh, a two-wheeler, every year say 10% is depreciation. After 10 years, its value becomes zero. Like that, EV vehicle, the battery has a limited life of assurance, say 3 years or 5 years. After that, we have to change the battery. And we are not doing the safe disposal. We are just throwing it in the atmosphere or in the common public unused place. Then what will happen? Again, it will deteriorate the atmosphere, as we already told. So all these things have to be keep it in mind, so that the e-vehicle ecosystem will gain the moment. Last and but not the least is the regulatory hurdles. As and when the new technology is introduced, the new e-vehicle is introduced, the state and central legislative authority are giving lot of stringent rules, and more costs also there. The RTO rules also we have to follow. Again, the charging is another problem. Charging stations are not available nearby or point. It will be available with vast and long distance. All these things are making a hitch in the customer to buy the new vehicle of EV when the paradigm shift from IC engine to e-vehicle. Global and domestic investors fueling India's EV growth. Normally, the foreign companies always will invest more money in India to attract their investment policy, and EV growth is gaining momentum in that. Our Indian companies is also equally coming very faster with the international companies. Job creation in manufacturing, engineering, and software is again another momentum. And various market examples are Ola Electric, already we told. They invested $500 dollars investment in the battery and R&D area. Coming to the challenges faced by the startups. First challenge number one is the transitioning to the V model. First, that is the first challenge. Second one is the end-to-end program management. Challenge 3 is the field testing complexities. Challenge 4 is the remote operations testing. Challenge 5 is the fleet data analytics. And challenge 6 is the enabling data quality assurance. Challenge 7 is the parallel vehicle development programs. Challenge 8 is the report preparation overheads. Challenge 9 is the lab simulation challenges. Challenge 10 is the unifying the validation operations. Challenge 11 is the modeling real scenarios. Challenge 12 is the leveraging the field scenarios for the lab test. These are all the various 12. These are all the various 12 challenges. These are all the various challenges faced by the startup. And these challenges we will see one by one. Number one is the transistoring to the V model. The demonstrated success of the V model in engineering complex system creates huge demand in the EV systems market for transitioning into the same improved competitiveness. However, moving to a model that emphasizes testing and validating the every developmental stage before proceeding to the next step in a sequence can be challenging experience for the EV makers. Enabling the data-driven engineering in every step is requires the seamless integration of feedback from the validation phase attached to the respective step. The challenge needs to be solved if EV makers want to build and launch efficient systems in less time and capture market leadership. See, this challenge number one is the is called as the V model. Normally, the people will have the tendency paradigm shift from the one concept to other concept. So, the transition stage, we are facing this challenge. Also, it is a data-driven engineering because always data will give the information. Always data is called as wealth. What are all the various activities, engineering activities are taken place in the vehicle? All data has to be captured and to be recorded and to be statistically analyzed and has to be converged into the normal action so that the vehicle will give the e-vehicle will give the very good performance. For example, one case study I can tell here, the conventional IC engine, if you connected with a test setup, we have three DACT will give the data acquisition system will give the three cycles. One is called the upper mode cycle, another one is called the middle mode cycle, and the another one is called the lower mode cycle. We will get the through data we will get the various cycles. These cycles has to be categorized in three different categories, namely the upper mode cycles UMC, middle mode cycle MMC, and the LMC, that is lower mode cycle. We are not interested to have any vehicle to be run in the upper mode cycle and the lower mode cycle because upper mode cycle will have lot of emissions and lower mode cycle will have the torque problem. So what we are going to do means we will convert the engine to run for our conditions. That is, we want all the cycle into a middle mode cycle. We don't want the upper mode cycle and lower mode cycle. We want to run the engine or run the automobile in the middle mode cycle only. So the research is there. What are all the various contributing factors for the upper mode cycle? What are all the contributing factors for the lower mode cycle? All these factors has to be captured through data and has to be statistically analyzed, as I already told, and it should be converted as a converged data. And we are again interested in the middle mode cycle so that my vehicle or my automobile will have less pollution and it will give us the maximum efficiency. We all know very well the thermal efficiency lies between the 25 to 30, the mechanical efficiency 80 to 90, and we are interested in increasing the brake thermal efficiency. As all the mechanical engineers in this participant list, you all know the various heat analysis. There are 5 various factors. Heat created because of the burning of fuel, that will be useful heat energy output in heat balance heat, that is the power available at the crankshaft, that is the brake power, that will have roughly 25%. Second heading is the heat carried away by exhaust gases, that will roughly about 25%. Third one is the heat carried away by cooling water. So 75% of the energy has been consumed roughly. For a small and simple understanding, if the persons of the participants is not belong to mechanical engineering or thermal field. So in 100%, the 3 portions is already consumed. Useful brake thermal efficiency, heat carried away by exhaust gas, heat carried away by cooling water. And another thing, last portion is the heat unaccounted. In the heat unaccounted, in heat balance heat comes the, there is a leakage in connections and various difference in the already 3 discussed topics. All these things comes under the heat unaccounted, so that we will have the 100% heat balance heat. So this cycle, what I have discussed, upper mode cycle and middle mode cycle and lower mode cycle, is directly correlated with this heat balance heat. And our aim and our idea, our concentration is only on the first heading is to increase the brake thermal efficiency. I want to get the maximum output from the fuel which I have introduced in the engine cylinder, so that the hydrogen and carbon atoms, hydrogen completely burning in nature, carbon again after burning it will exist there. So you all know very well that petrol engine and diesel engine. Petrol engine is an engine, it is called as love marriage engine. There is a place called park there that is equivalent to the carburetor. Carburetor is a device which will mix the fuel and air in appropriate condition, the requirements of the loading driving condition of the engine. So it will be thoroughly mixed in the carburetor, and it will be first stroke is the suction stroke, second stroke is the compression stroke. It is admitted in the suction stroke itself, first stroke. So proper homogeneous mixture of air fuel is allowed inside the engine cylinder, and it gets compressed in the second stroke. In the third stroke, there is an external device is called the spark plug, because self-ignition temperature of the petrol or gasoline is very high, that is roughly about 650 degrees centigrade. Then if we need an external source to ignite, that spark plug is used, and we are getting the energy or output or brake thermal efficiency in the third stage, that is power stroke, suction stroke, compressor stroke, power stroke. Fourth stroke, naturally the exhaust stroke, all burnout gases is allowed to the atmosphere. That's why petrol vehicles are less polluting vehicles, because the combustion takes place in a homogeneous manner. Combustion takes place at a single site inside the engine cylinder. So there is a possibility of try to near zero or near 100% combustion of the carbon atoms. So the exhaust pollution is very less. That's why colloquially we can say, as our senior most professor of IIT Chennai, Ganeshan sir, used to tell in all FDP's various symposium conferences, he only told this. I am just adopting as a student from him. The petrol engines are often called as love marriage engines, because there is a place called park to have the love with the petrol and the atmospheric air, that is hydrocarbon is going to mix with the homogeneous mixer inside the combustion chamber, and that's why the petrol engines will have less emission. But in contradictory, coming to the other side of the coin, coming to the diesel engine, it is always called as arranged marriage engine. The boy has not seen the girl, girl has not seen the boy. They are meeting only in the marriage stage. Only seniors, parents, uncles are going to finalize the marriage like that. During suction stroke, only atmospheric air is allowed inside the engine combustion chamber, and it is getting compressed in the second stage, in the compression stage. In the third stage, the diesel fuel injector is there. It will inject the diesel fuel according to the running condition of the engine, and combustion takes place. That's why diesel combustion is always called as heterogeneous combustion. That means, in simple term, combustion takes place at multiple sites. It is the will and pleasure of the hydrocarbon atom which is available in the fuel to join hand with the oxygen which was injected during suction stroke. If they meet with each other, combustion takes place, and again it will be a incomplete combustion, because combustion takes place at multiple sites. By this combustion phenomena, by this chemical reaction, the diesel engine will emit more. That's why we have more NOx, SOx, everything in diesel engine. That's why the after treatment is more important. All these things are there. And at times, the two-stroke engines are called often to a particular category unmarried engine, because suction stroke and during suction valve and transfer port and exhaust, because during exhaust stroke, some of the fresh charge without involving in the combustion process, it will emit with the exhaust gas. That's why often it is called as unmarried engine. See, this love married engine, arranged married engine, and uh, um, unmarried engine are told very colloquially to understand the dynamics and concept of the engine combustion process. Nothing else. Don't all others don't mistake me. Now, coming to the challenge 2. This challenge 1, what we have so far discussed about the IC engine, particularly the petrol fuel and diesel fuel, or the two-stroke, all these problems are minimized, or it will be have the near zero condition coming to the e-vehicle, because in e-vehicle all this pollution is very, very less or near to zero. These are all the various challenge for the R&D makers for the engine process. And the second challenge is the development involves the multiple and parallel sequential work streams. And the third challenge is the field testing complexities. Being a mobility product, it is very important to have various validation in various stages in place for the actual field deployment and performance of the vehicle. That is the another challenge that is called field testing complexities. In one forum, we have discussed with the Silicon Valley people. They are telling that chip design people are only 10 percentage are needed. Only chip testing people are needed 90 percentage. In another 40 to 50 years, chip testing people will have more job opportunity compared to the chip design people. Like that, this third challenge is coincidence with this field testing complexity. Being a mobility product, it has to be tested and validated and converged in optimized manner. Then only the new technology will be adopted by the people. Now coming to the challenge 4, the remote operations testing. EV makers often require remote operations for utilities, manpowers, test data, and test beds. From a testing and validation perspective, this results in additional liability. That is another challenge. Next, move on to the fifth challenge, that is the fleet data analytics. To improve EV performance and empower future innovations, it is extremely important to have a deep and drill down the granular insight into the fleet data, which can be obtained through high-end data analytics. Pairing the right volume of the fleet data with the right analytical tool, it is again a challenging one. Since it is being done, if it's the test bed, if it is a research e-vehicle, no problem. If it is tested on road, when the vehicle is running on the road, data is being captured by the DAC system in a remote manner. We should have that kind of capability and capacity of the data analytics and data acquiring system. Then only the data will be a real one. Otherwise, if any data mistake is there and data manipulation is there, it will not give the correct output. And based on the output, if we do any R&D modification, that will affect the e-vehicle's performance. All these things has to be keep it in mind. Again, this itself a vast area that we will address as and when required in some other forum. Coming to the challenge 6, enabling data quality assurance. All these data quality with the multiple systems involved across the length and breadth of the organization, it is natural to have the several data streams flowing into the core processes for the EV business. That also has to be addressed. Another challenge is the parallel vehicle development programs. EV makers may have to deal with developmental programs for multiple vehicles concurrently or parallelly, or multiple component development initiatives parallelly for the same vehicle. So that is another challenge in the e-vehicle. Next, eighth challenge is the report preparation and overhead, and that also attracts more cost and more problems and involves more money to carry out that. And lab simulation challenge. Before going to have any real product, we do simulation in the laboratory or simulation in the desktop itself. This simulation, again, testing and reporting of performance are carried out. EV makers rely upon the test laboratories for experimenting with unique use cases. Labs which should have the various simulation capabilities that provide real results in in-field conditions, and the performance of components in lab simulations must be validated. Coming to the 10th challenge is unifying the validation operations. All the data has to be analyzed properly and has to be converged properly and has to be validated also properly. Then only we will have the proper output. 11th challenge is the modeling real-time scenarios. We do modeling and also it has to match the real life or real-time data. Then only we have to match the real model into the imaginary model into the real model. Then only the design will be optimum and R&D will be a successful one. This is again challenging area because the data is obtained from on-road tests. While acquiring the data, whether the data capture device is in the proper condition, we have to ensure. Since the vehicle is running at 100 km per hour, who will ensure the data capturing is correct or data capturing is in online? Who will cross-check, who will ensure all these cross-checking mechanism is another challenge. Last but not least, the leveraging the field scenarios for lab test. Configuring the test lab for modeling every possible field scenario is a time-consuming task. If EV makers stick with the manual configuration, the validation process will affect other critical launch plans owing to delays and inefficiencies. So delayed data is again another dangerous data, and inefficiency if comes out of this uh, data validation, again it will affect the R&D. These are all the various 11 challenges has been categorized in the EV development and validation. It is not a final one. These are all the majority of one. Beyond these 12 challenges are also there in EV development, since development is not a one-day effect process. Success is not an one-day activity. Success is a lifelong journey. So we will face the challenges, even the 13th, 14th, etc. challenges will be there. That is not mentioned here because these 12 are the major challenges that has been listed out here. Coming to the future outlook and opportunities, more government and support incentives, investments are needed. Advancements in battery tech, that is solid state and hydrogen fuel cells, expansion of charging networks, global expansion for Indian startups. Normally, when we do have startup, either our competitive country or the other foreign nations will be much ahead in advance. So we have to understand the dynamics of that startups that has to be incorporated in our startups, then our startup will gaining momentum. Then coming to the EV business opportunities and models in India. So this is a diagram which has been acquired from the internet. We acknowledge the internet for EV development. Various things are there. What are all the facilities available? What are all the renewable energy available? And what are all the various support system for the EV business opportunity has been listed here. Before move on to the next topic, I will open the floor for the audience to clarify anything, because it should not be a monologue one. It should be a two-way communication. Dear audience, do you have any clarification? Okay, if no clarification or doubts, next move on to one video session, the EV business opportunities, that is the electric vehicles, role of startups in India with the EV ecosystem.
Imagine India, a country of endless possibilities, where the future of transportation isn't just a fantasy but a reality being shaped by a wave of electric vehicle startups. These startups are doing more than just putting wheels on the ground. They're rewriting the rules of the road. While traditional automotive giants like Tata and Mahindra have made their mark with their EV offerings, it's the startups that are truly electrifying the scene. They're not just joining the EV revolution, they're leading it with the accelerator floored. Whether it's affordable three-wheelers for urban jungles or sleek, high-speed motorcycles that make petrol heads think twice, these companies are proving that the future is not just electric. It's innovative, efficient, and undeniably cool. So, buckle up as we dive into the top 10 Indian EV startups that are driving India towards a greener future. Welcome to the AI Lib. Kicking off our list at number 10 is Strom Motors, a startup that's giving the classic three-wheeler a much-needed jolt of electricity. Founded in Mumbai in 2016 by Pradeep Gupta, Jean-Luc Abizio, and Dr. Gilmer Blankenship, Strom Motors isn't just another player in the EV game. They're innovators with a mission to make electric vehicles accessible to the masses without compromising on style or tech. Now, let's talk about their flagship vehicle, the Strom R3. At first glance, the R3 might look like something straight out of a sci-fi movie. A compact, futuristic trike that's designed to weave through India's bustling streets with ease. But this isn't your average three-wheeler. The R3 is an electric marvel, priced at an affordable range of 4 to 4.5 lakh rupees, approximately $5,400 to $6,000, making it a realistic option for budget-conscious consumers who don't want to sacrifice innovation for cost. What makes the Strom R3 so special? For starters, it's packed with technology that would make even the most tech-savvy drivers swoon. It features a 4G, connected diagnostic engine that not only tracks the location and charge status of the vehicle, but also provides a complete health report of critical components like brake pads, motors, and electronics. Imagine having a car that's basically a smart device on wheels, constantly monitoring its own health and adjusting its performance based on the road conditions and your driving habits. That's the kind of next-level technology Strom Motors is bringing to the table. But the R3 isn't just about smart tech. It's about smart design, too. This compact EV is perfect for navigating India's crowded urban environments, where space is a luxury and maneuverability is key. The R3's design focuses on efficiency and practicality without skimping on aesthetics. It's a vehicle that's as comfortable zipping through city traffic as it is parked in a tight spot. Plus, with machine learning-based navigation that learns and adapts to your daily driving routes, the R3 is like having a co-pilot who knows the roads as well as you do. Strom Motors isn't stopping at just making a cool, affordable EV. They're also thinking ahead about the future of urban mobility. The company plans to start delivering the first batch of R3s by January 2021, and they're already setting the stage for scaling up production to meet what they anticipate will be high demand. They're not just creating a product. They're creating a movement towards more sustainable, accessible urban transportation. In terms of funding, Strom Motors has attracted significant interest, with investors keen to back a startup that's not just innovative, but also practical in its approach. Their focus on creating a cost-effective, technologically advanced vehicle for the Indian market has positioned them well in the growing EV space. They're not just building cars, they're building a brand that stands for innovation, sustainability, and affordability. So, why is Strom Motors in our top 10? It's simple. They're challenging the status quo. In a market dominated by conventional two-wheelers and four-wheelers, they've carved out a niche with their unique three-wheeler, proving that sometimes the best way to innovate is to rethink the basics. Strom Motors is doing more than just participating in the EV revolution. They're leading it with a vision that's as bold as it is practical. Keep an eye on them because they're not just driving change, they're redefining what it means to be an urban commuter in India. At number 9, we have Euler Motors, a startup that's taking the humble rickshaw and giving it a Tesla-inspired makeover. Founded in 2018 by Saurav Kumar, Euler Motors is not just another EV company. It's a trailblazer that's redefining cargo transportation in India's chaotic urban landscapes. Euler Motors set out with a clear mission: to revolutionize the way goods are moved across India's cities. Their answer? An electric auto rickshaw designed specifically for the cargo segment. This is no ordinary rickshaw. It's a robust, high-tech, and eco-friendly solution that's already turning heads in the industry. Think of it as the love child of a traditional Indian rickshaw and a Tesla: smart, efficient, and built to last. The company's flagship product, an electric three-wheeler designed for urban logistics, is more than just a green alternative. It's a full-stack ecosystem, complete with charging and service station networks. Euler Motors isn't just selling vehicles. They're offering a comprehensive mobility solution, ensuring that their rickshaws stay charged, maintained, and ready to roll at all times. But what makes Euler Motors truly stand out is their approach to the market. They've partnered with leading e-commerce giants like Big Basket, Ecom Express, Blue Dart, Uden, and Milk Basket, integrating their electric rickshaws into these companies' logistics operations. This isn't just smart, it's visionary. By embedding their vehicles into the supply chains of India's largest online retailers, Euler Motors is ensuring that their products are not just seen but relied upon by the nation's biggest businesses. Let's dive into the tech behind these rickshaws. Powered by a 12 kilowatt-hour battery pack, Euler's electric rickshaw boasts a range of 150 kilometers on a single charge, more than enough to cover the daily routes of most urban delivery drivers. And thanks to its robust build and advanced engineering, this vehicle can handle payloads of up to 500 kilograms without breaking a sweat. But that's not all. Euler Motors has also developed a network of over 100 charging stations in the Delhi NCR region. This is where their vision of a full-stack ecosystem really shines. By providing the infrastructure necessary to keep their vehicles running smoothly, they're removing one of the biggest barriers to EV adoption: the fear of running out of juice. With charging stations strategically placed throughout the city, Euler's rickshaws are always within reach of a quick top-up, ensuring that drivers can keep moving without downtime. On the financial front, Euler Motors has been making waves as well. The startup has raised over $4.7 million, 35 crore INR, from a mix of venture capital firms and strategic investors, including Bloom Ventures, Inventus Capital, Singapore-based Jetty Ventures, and Udin co-founder Sujit Kumar. This funding has allowed them to expand their operations and continue refining their technology. And with a valuation of around $12.5 million, 93 crore INR, as of mid-2020, Euler Motors is well positioned for rapid growth as India's EV market continues to heat up. So, why does Euler Motors deserve a spot in our top 10? It's because they're not just electrifying rickshaws, they're electrifying an entire industry. By focusing on the cargo segment and building a complete ecosystem around their vehicles, Euler Motors is solving the real-world problems that have traditionally hindered EV adoption in India. They're not just selling a product. They're selling a future where urban logistics are clean, efficient, and sustainable. Euler Motors is a startup that's thinking big and delivering on those big ideas. Coming in at number 8 is Influx Motors, a startup that's setting the stage for a high-speed, high-tech future with India's first electric superbike. Founded in Bengaluru in 2016 by Ankit Kshatriya, Varun Mittal, and Vinay Raj, Influx Motors is on a mission to make electric superbikes that are not only fast but also accessible. Let's talk specs. The Influx One, their flagship model, is an electric superbike designed to blow the doors off anything else on the road. With a top speed of 200 kilometers per hour and an acceleration from 0 to 100 kilometers per hour in just 3 seconds, this bike isn't just fast, it's blisteringly fast. And with a range of 200 kilometers on a single charge, it's not just a track day toy. It's a legitimate option for everyday riders who crave speed without the environmental guilt. The Influx One is more than just a pretty face. It's a technological marvel. The bike is powered by a liquid-cooled AC induction motor, which is coupled with a Samsung lithium-ion battery pack. This setup provides not only the raw power needed to hit those impressive top speeds, but also the reliability and durability required for daily use. And with features like regenerative braking, the Influx One is as smart as it is fast, ensuring that every joule of energy is put to good use. But the story of Influx Motors isn't just about the bike. It's about the ecosystem they're building around it. The company is working on creating a network of partner OEMs, original equipment manufacturers, to supply EV-related technology and components. This strategy isn't just smart. It's essential for scaling up production and ensuring that the electric vehicle revolution reaches as many riders as possible. One of the most impressive things about Influx Motors is their ability to adapt and innovate. In May 2020, during the height of the global pandemic, the company pivoted temporarily to produce personal protective equipment, PPE, including face shields. This move not only helped address a critical shortage of PPE in India, but also demonstrated the company's agility and willingness to step up in a time of need. It's this kind of flexibility that sets startups like Influx apart from their larger, more traditional competitors. Financially, Influx Motors has raised a total of $538,000, 3.9 crore INR, to date. While this might seem modest compared to some of the other startups on this list, it's important to remember that Influx is playing a long game. Their focus isn't just on making a quick buck, it's on building a brand that stands for speed, technology, and sustainability. And with a valuation of $2 million, 14.8 crore INR, as of 2018, they're well on their way to making that vision a reality. So, why does Influx Motors make our list? Because they're not just making an electric bike, they're making a statement. In a world where electric vehicles are often seen as slow and practical, Mflux is proving that they can be fast, exciting, and downright cool. They're challenging the notion that going green means compromising on performance, and they're doing it in style. Mflux Motors is more than just a startup. It's a revolution on two wheels. At number 7, we have Okinawa, a Gurugram-based startup that's making electric two-wheelers affordable for the masses. Founded in 2015 by Rupali Sharma and Jitinder Sharma, Okinawa is on a mission to bring EVs to every corner of India. And they're doing it by creating electric scooters that are not only budget-friendly but also packed with features. Okinawa's flagship product, the iPraise Plus, is a perfect example of their approach. Priced at just 1 lakh rupees, around 1,300 US dollars, the iPraise Plus isn't just affordable, it's a steal. But don't let the low price fool you. This scooter is anything but basic. With a top speed of 58 kilometers per hour, swappable batteries, and a smartphone app that lets you track the scooter's location, immobilize it remotely, and check its battery status, the iPraise Plus is a high-tech ride that doesn't break the bank. One of the things that set Okinawa apart is their focus on creating products that look and feel familiar to Indian consumers. Unlike some other EV manufacturers that focus on futuristic, high-tech designs, Okinawa's scooters look, at first glance, like any other two-wheeler on the road. This is intentional. The company isn't trying to create a scooter that stands out as an EV. Instead, they're focused on making a scooter that fits seamlessly into the lives of their customers, while quietly packing it full of smart features that set it apart from the competition. But Okinawa isn't just about selling scooters. They're about creating a movement. The company's goal is to make electric two-wheelers the norm, not the exception, in India. And with products like the iPraise Plus and the Oki 100 electric bike, they're well on their way to achieving that goal. The Oki 100, in particular, is a bike designed to compete directly with other popular electric bikes on the market, offering a blend of performance, affordability, and practicality that's hard to beat. Okinawa's success isn't just due to their product lineup, it's also a result of their savvy business strategy. The company has focused on creating a robust distribution network across India, ensuring that their products are available to customers in even the most remote parts of the country. This strategy has paid off. Okinawa is now one of the leading players in the Indian EV market, with a growing customer base and a reputation for reliability and innovation. Financially, Okinawa is in a strong position. The company has seen steady growth since its inception, fueled by a combination of product sales and strategic partnerships. And with the Indian government's continued push towards electric mobility, Okinawa is well positioned to capitalize on the growing demand for affordable, eco-friendly transportation options. So, why does Okinawa make our list? Because they're not just making electric scooters, they're making electric scooters for everyone. By focusing on affordability, practicality, and accessibility, Okinawa is ensuring that the benefits of electric mobility are available to all, not just the elite. They're democratizing the EV revolution, one scooter at a time. Taking the 6th spot on our list is Revolt Motors, a company that's blending artificial intelligence with electric mobility to create a motorcycle that's as smart as it is sleek. Founded in Gurugram in 2019 by Rahul Sharma, one of the co-founders of Indian smartphone giant Micromax, Revolt Motors is on a mission to make AI-powered electric bikes the new standard in India. Revolt's flagship models, the RV300 and RV400, are more than just electric motorcycles. They're intelligent machines that learn and adapt to their riders. Powered by AI, these bikes come equipped with features like geofencing, geolocation, battery swapping, and even customizable engine sounds. Yes, you heard that right. If you're not a fan of the traditional silence of an electric bike, Revolt's AI can generate sounds that mimic a conventional engine, giving you the roar of a petrol bike without the emissions. But it's not just about the tech. These bikes are designed to be practical and accessible. The RV400, for example, boasts a top speed of 80 kilometers per hour and a range of 85 kilometers on a single charge. And with swappable batteries, you can extend that range even further without waiting for a recharge. This makes the RV400 not just a bike for the environmentally conscious, but also a viable option for everyday commuting. Revolt Motors has quickly gained a following in India, with their bikes selling faster than they can produce them. This surge in demand has prompted the company to announce plans to raise $100 million, 743 crore INR, to expand their production capacity and roll out their bikes in new cities across the country. This isn't just a sign of the company's success. It's a clear indication that Indian consumers are ready for a new kind of motorcycle, one that's smart, sustainable, and stylish. Financially, Revolt Motors has benefited from substantial investment, including a personal investment from Rahul Sharma himself, who has poured between 400 and 500 crore INR, approximately $54 to 67 million US dollars, into the company. This financial backing has allowed Revolt to scale rapidly and continue innovating in a competitive market. So, why is Revolt Motors on our list? Because they're not just making electric bikes, they're making smart electric bikes. By integrating AI into their vehicles, Revolt is pushing the boundaries of what's possible in the EV space, creating motorcycles that are not only green but also intelligent and adaptive. They're proving that the future of mobility isn't just electric, it's smart too. Coming in at number 5 is Ultraviolet Automotive, a Bengaluru-based startup that's setting new standards for high-performance electric motorcycles. Founded in 2015 by Neeraj Rajmohan and Narayan Subramanian, Ultraviolet is on a mission to create electric bikes that don't just match their petrol-powered counterparts, they outperform them. The F77, Ultraviolet's flagship model, is a testament to this mission. This electric motorcycle is designed to thrill, with a 0 to 60 km per hour acceleration time of just 3 seconds and a top speed of 147 km per hour. But the F77 isn't just about speed. It's about precision, control, and performance. With a range of 130 to 150 kilometers on a single charge, this bike is as practical as it is powerful, making it a viable option for both city commuting and weekend joyrides. One of the standout features of the F77 is its modular battery system. The bike comes with 3 removable batteries that can be swapped out in seconds, allowing riders to extend their range without waiting for a recharge. This feature is particularly appealing in a country like India, where charging infrastructure is still in its infancy. By allowing riders to carry spare batteries, Ultraviolet is solving one of the biggest challenges facing EV adoption: range anxiety. But it's not just the bike's performance that's turning heads, it's also the tech. The F77 is fully connected to a mobile app, which allows riders to track their bike's location, monitor battery status, and even customize the bike's performance settings, such as max speed and torque. This level of connectivity and customization is something you'd expect from a high-end sports car, not a motorcycle, and it's a clear indication that Ultraviolet is pushing the boundaries of what's possible in the two-wheeler segment. Financially, Ultraviolet has secured significant backing, including a $4 million investment from TVS Motors, which now owns nearly 30% of the company. This investment has allowed Ultraviolet to scale up production and continue developing their technology. The company is also in the process of raising an additional $71 million across its ongoing Series B and Series C funding rounds, further solidifying its position as a leader in the electric motorcycle market. So, why does Ultraviolet make our list? Because they're not just making electric bikes. They're making high-performance electric bikes that can go toe-to-toe with the best petrol-powered motorcycles on the market. Ultraviolet is proving that going green doesn't mean giving up speed, power, or excitement. It just means doing it smarter. In 4th place, we have Torque Motors, a Pune-based startup with a rich history of racing and innovation. Officially founded in 2016 by Kapil Shelke, Torque Motors' journey actually began much earlier, in 2005, when Kapil and his team built their first electric motorcycle for the Isle of Man TT, one of the most dangerous and prestigious motorcycle races in the world. Torque Motors' early success on the racetrack laid the foundation for what would become one of India's most promising electric vehicle startups. Their first commercial product, the T6X, is a testament to their racing pedigree. This electric motorcycle is designed for both speed and efficiency, with a top speed of 100 km per hour and a range of 100 km on a single charge. But what sets the T6X apart is its AI-enabled operating system, TORK Intuitive Response Operating System, TIROS, which learns and adapts to the rider's habits to optimize performance and energy consumption. The T6X isn't just about raw performance. It's also packed with features that make it a joy to ride. From a mobile app that provides real-time updates on the bike status to a fast charging system that can recharge the battery to 80% in just 1 hour, Torque Motors has thought of everything to make the T6X a practical and desirable option for Indian riders. Torque Motors is also backed by some heavy hitters in the business world, including Bharat Forge, which owns 49% of the company, and Ratan Tata, who has personally invested in the startup. This financial support has been crucial in helping Torque Motors scale up production and bring the T6X to market. So, why is Torque Motors on our list? Because they're not just building electric bikes, they're building bikes that are rooted in racing and innovation. Torque Motors is a company that's blending speed with sustainability, proving that you don't have to choose between performance and the environment. They're racing towards a future where electric motorcycles are the norm, not the exception, and they're doing it with style and substance. Taking the third spot on our list is Yulu, a Bengaluru-based startup that's redefining urban mobility with its electric scooter rental service. Founded in 2017 by Amit Gupta, Naveen Dachuri, R.K. Mishra, and Hemant Gupta, Yulu isn't just about selling scooters. It's about changing the way we think about transportation in cities. Yulu's business model is simple yet revolutionary. Instead of selling electric scooters, they rent them out to users on a pay-per-use basis. All you need to do is download the Yulu app, find a scooter near you, and you're ready to ride. It's a system that's designed for convenience, affordability, and sustainability, making it an ideal solution for short trips in congested urban areas. The Yulu Miracle, their flagship electric scooter, is a compact, lightweight vehicle that's perfect for zipping through city streets. It's powered by a lithium-ion battery that provides a range of 25 to 35 kilometers on a single charge, which is more than enough for most urban commutes. And with a top speed of 25 kilometers per hour, it's safe and easy to ride, even for those who aren't experienced motorcyclists. But Yulu isn't just about scooters. They're about creating a holistic urban mobility solution. The company has partnered with local governments and public transit systems to integrate their scooters into the larger transportation network, making it easier for people to get around without relying on cars. This not only reduces traffic congestion, but also helps cut down on air pollution, making cities cleaner and more livable. Financially, Yulu has attracted significant investment, including $19.9 million from investors like Bajaj Auto, which now owns a 16.67% stake in the company. This funding has allowed Yulu to expand its operations across multiple cities in India, and they're now looking to take their model international. So, why does Yulu make our list? Because they're not just making scooters, they're making cities better places to live. By providing an affordable, convenient, and sustainable alternative to cars, Yulu is helping to transform urban transportation in India and beyond. They're proving that the future of mobility isn't just about the vehicles we drive. It's about the way we move. Taking the silver medal on our list is ATAL Energy, a Bengaluru-based startup that's leading the charge in the electric scooter market. Founded in 2013 by Swapnil Jain and Tarun Mehta, ATAL Energy has quickly become one of India's most prominent EV companies, thanks to their innovative products and forward-thinking approach. ATAL's journey began with the ATAL S340, India's first smart electric scooter. But it was the ATAL 450 and its successor, the ATAL 450X, that really put the company on the map. These scooters are packed with features that you'd expect from a high-end smartphone, not a two-wheeler. We're talking about an LCD dashboard with Google Maps integration, music playback, call answering capabilities, and even an incognito mode for those who prefer a little privacy while riding. But ATAL's scooters aren't just about tech, they're about performance. The ATAL 450X, for example, boasts a top speed of 90 kilometers per hour and a range of 116 kilometers on a single charge, making it one of the most capable electric scooters on the market. And with a charging infrastructure known as ATAL Grid, the company is ensuring that their customers are never far from a quick recharge, with stations strategically placed in major cities across India. ATAL Energy's success hasn't gone unnoticed. The company has raised a whopping $140 million from investors, including Hero MotoCorp, which owns nearly 38% of the company, as well as Innova Capital and Tiger Global. This financial backing has allowed ATAL to scale up production and expand their presence across India, with plans to go international in the near future. So, why is ATAL Energy at number 2? Because they're not just making scooters, they're making scooters that are smart, stylish, and sustainable. ATAL is leading the electric scooter revolution in India, proving that EVs can be as desirable as they are practical. They're setting the standard for what an electric vehicle should be, and they're doing it with flair. And finally, at the top of our list is Ola Electric, the Bengaluru-based startup that's set to dominate the EV market not just in India, but globally. Founded in 2017 as a subsidiary of the ride-hailing giant Ola, Ola Electric has quickly become a force to be reckoned with in the electric two-wheeler market. Ola Electric's journey began with the acquisition of Amsterdam-based Atergo, a company known for its app scooter, a high-tech, long-range electric scooter that set new benchmarks for the industry. Ola didn't just buy the company, they brought its technology and expertise to India, where they've set up the world's largest electric two-wheeler manufacturing facility. Spread across 100 acres, this factory is a testament to Ola's ambition and commitment to transforming the way we move. The app scooter, now branded as the Ola S1 and S1 Pro, is a game changer. With a range of up to 240 kilometers on a single charge, thanks to its modular battery system, a top speed of 115 kilometers per hour, and smart features like a touchscreen dashboard, voice control, and a music system, the Ola S1 is more than just a scooter. It's a tech-laden powerhouse on two wheels. It's designed to offer the best of everything: speed, range, tech, and style. But Ola Electric's vision goes beyond just selling scooters. They're aiming to put 1 million EVs on the road by 2021, and they're doing it by making electric vehicles accessible to the masses. With a starting price of around 1 lakh INR, approximately $1,350, the Ola S1 is priced competitively, ensuring that it's within reach for a wide range of consumers. Financially, Ola Electric is a juggernaut. The company has raised over $307 million from investors like SoftBank, Hyundai, Kia, and Tata, and is valued at over $1 billion. This funding has enabled them to scale rapidly and invest in the infrastructure needed to support their ambitious goals. So, why does Ola Electric top our list? Because they're not just participating in the EV revolution, they're leading it. Ola Electric is setting the pace for the entire industry, both in India and globally. They're proving that electric vehicles aren't just the future, they're the present. And with their bold vision and relentless drive, Ola Electric is well on its way to becoming a global leader in sustainable mobility. So, what do you think? Are these startups the future of mobility in India? If you enjoyed this video, please give it a thumbs up.
Hello. Hello, is it audible?
Yes, sir. Yes, sir.
Okay.
Yes, sir, it is audible.
Only audible, sir.
Yes, sir. It is audible, sir.
Yes, sir. Now only it's audible, sir.
Hmm.
Sir?
Can't receive clearly, sir.
Again, welcome back to the same session. I hope you have all witnessed that video that is more relevant to that. Now, a small portion is there in the first session itself. Let us concentrate on that. Outlook and facts of global and Indian EV market. The global market for the electric vehicles is expanding very quickly. According to EV volumes, with 6.75 million vehicles on the road, the overall global percentage of electric vehicles, which includes the battery electric vehicles, that is BEVs, and plug-in hybrid electric vehicles, PHEVs, rose to 8.3% in 2021 from 4.2% in 2023. By 2023, there will be a beginning of 108% growth. Now it is 2025. These figures will be increased in a phenomenal range. As they aid in lowering the pollution and resource depletion, EVs are gaining popularly all over the world. The Indian EV market is likewise developing very quickly. In 2022, close to 0.32 million vehicles were sold. A 168% of year after year increase was there. The Indian government has always been in the forefront of developing the national EV adoption strategies. Various strategies has been adopted in India. The first scheme is the FAME scheme, in order to encourage the development of early use of hybrid and electric vehicles in the nation. The FAME India scheme, faster adoption and manufacturing of hybrid electric vehicles, are the abbreviation for the FAME. Electric vehicle was introduced in the year 2015 with a budget of US $1.3 billion. That is roughly about 10 crores for Indian money. The FAME 2 scheme was introduced in India to support 1 million E2-wheelers, that is 0.5 million E3-wheelers, 55,000 E-passenger vehicles, and 7,000 E-buses. The scheme was extended by the government until 2024, has started in the Union Budget 2022-23. See, all these figures are encouraging in nature, and this will gain the momentum for the EV ecosystem for a startup in India. Then battery swapping policy also introduced. Adoption of EVs depends upon the availability of the widespread of charging infrastructure. The Niti Aayog was published a proposed battery swapping policy in this regard on April 22 in the year 2022, and it will be in effect until March 31st of 2025. Still 1 month, 2 months are there. Now we are in January, February, and March. All metropolitan areas with a population of more than 4 million will be covered by the policy, which will be implemented over a period of 1 or 2 years from the moment it is introduced. All the union territories and significant cities with a population of more than 5,000 will be introduced in the second phase, which will be implemented over the course of 2 or 3 years after the policy's launch. See, countries like India, we cannot implement any new approach at a stretch. It has to be implemented stage by stage and based on the crowd or the status of the city, like metropolitan, etc., union territories, etc. So likewise in India, we have in 1 year, in 2 years, in 3 years, stage by stage, we are adopting this battery swapping policy. Then PLI scheme, the government has launched the PLI ACC, that is production linked incentives for advanced chemistry cell battery storage scheme. The program is anticipated to strengthen India's battery infrastructure. According to the union budget, the scheme's entire outlay is US $2.45 billion. That is roughly the 1,800 crores of Indian money, which will be distributed to the beneficiaries over the course of 5 years once the manufacturing facility is established. See, all these systems and schemes are very much encouraging for EV industry's growth and EV ecosystems. Various other incentives which was given by the governments are the Section 80EE, the Energy Efficient Bureau of the Income Tax, allows for the tax exemption up to rupees 1,50,000, that is US dollar of 1,960, when financing the purchase of an e-vehicle, either 2 watts or the 4 watts. The customer taxes on a nickel ore, a crucial component of lithium-ion batteries, are being reduced from 5% to 0%. Road tax reductions and other incentives are at the state level has been implemented. See, all these other incentives, again, it is an encouraging factor for the EV ecosystem and the new EV startup industry. Coming to the business opportunities, the Indian government's push for the e-vehicles, that is electric vehicles, create a wide range of economic prospects in the infrastructure, energy and mobility sectors. Among them are the possibilities in the EV, OEM market, battery infrastructure, solar car charging, battery swapping technology, and many more areas. Niti Aayog estimates that a total investment of US dollar 267 billions approximately for Indian money rupees 19.7 lakh crore in EVs, battery infrastructure and charging infrastructure is needed to make the full transition to EVs. That is, to make the full transition means from the conventional IC engine concept to the electric vehicle concept. The Indian government and the automotive industry have the common objectives which are encapsulated in the Automotive Mission Plan, that is AMP 2016 to 2026, that is the 10-year plan. In accordance with the AMP 2016 to 26, the sector is anticipated to contribute more than 12% of the country's GDP, of which 7.1% has been reached thus far. It hopes to make up to 40% or more of the manufacturing sector by the end of 2026. Still one more year is there. If these goals are reached, both India's automotive industry and country's benefits will be increasing in nature. A crucial additional aspect is that the country's internal lithium-ion battery production ambitions may reduce the price of EVs, lowering the dependence and perpetuating the import tax. India will therefore soon have a sizable market. Adding to this, the Ministry of Skill Development and Entrepreneurship, that is MSDE, estimates that by 2030, the EV sector might add 10 million direct jobs, which will result in 50 million indirect jobs. So in total, we will have the 60 million jobs in EV industry. The auto sector in India has had a substantial growth, and it is predicted to continue the growing rapidly. The pandemic has supersede the need for the products that lower the pollution levels, and EVs are the remarkable method to do this in terms of how the market is performing. Electric vehicles have a great deal of potential to lessen our carbon footprint and offer a sustainable and cost-effective means of transportation. Purchasing an electric vehicle is the only way to support the this environmental contribution. See, normally the people used to say that you no need to reinvent the wheel again. Already wheel is the revolution in mechanical engineering that contributes for not only in the all other fields of engineering, but also the various other fields like medical, agriculture, everything. In total, the entire world, world is enjoying the wheel's benefits. That's why people used to say, you no need to reinvent the wheel. Earlier, there was a wooden wheel. Then the years progress, now we have tubeless wheels, and we don't know in future what type of wheel is going to come. So all these things will contribute the various advancement of EV ecosystem. The startups are driving the India's EV revolution, no doubt in that. Startups are the main important key areas which will drive the India's EV revolution. The key focus are the affordability, infrastructure, sustainability. We call it as AAS. Affordability should be there for the common public. EV infrastructure should be there in the EV ecosystem, and all the EV parts, the entire whole, the EV vehicle should have the sustainability in nature. Finally, the collaboration with investors and the government for long-term success are needed. Thank you. We are in the end of the first session. Any clarification, any queries, I am happy to clarify and answer. Then we will move on to the second session. Participants, any clarification and queries? If there is no queries, let us move on to the second session. Before going to the second session, we will witness a short video.
Two decades ago, Tesla was just a wild idea, an electric car company that dared to defy the giants of the auto industry. Fast forward today, and the company hasn't just survived, it's completely rewritten the rules of the game. From its relentless push for the fully autonomous driving to the massive gigafactories churning out cars at unprecedented scale, Tesla has always been about the audacity. But what really sets it apart? It's the brain behind it all, the self-driving system architecture. Today, we are going to crack that open and explore how this has put Tesla light years ahead of its competitors. Did you know that Tesla Motors wasn't actually founded by Elon Musk? In fact, Elon wasn't a part of the original team. Tesla was started in 2003 by engineers Martin and Mark in San Carlos, California. The duo was inspired to create Tesla after GM recalled and destroyed its EV1 electric cars. This is a picture from the early 2000s showing a team responsible for launching EV1. Here is a short snippet showcasing a few of the remaining EV1 cars around the world. Most have ended up in research centers and are among the first fully electric vehicles developed and commercially launched. Elon later joined first as an investor and then as a chairman. Musk initially invested about $30 million to redesign this platform. Under his leadership, Tesla has no doubt transformed the automotive industry. From the launch of this version of Roadster in 2006 in California that you see out here, to the launch of Model S and X, Tesla has pushed the boundaries of these vehicles. These models have set new benchmark for electric vehicles. The highly anticipated Cybertruck, with its futuristic design and rugged durability, represents Tesla's boldest leap yet, pushing the limit of what electric vehicles are capable of achieving in terms of versatility, strength, and off-road capability. Today, we are going to explore one of Tesla's most ambitious projects, full self-driving, which aims for level 5 autonomy, complete driving with zero human intervention. Before diving deep into Tesla's FSD system, it's important to understand what a standardized architecture looks like. It actually includes 4 core components. First one being perception. It's important to understand the world around the vehicle, and that's the job of the perception module. Then we have localization. This module allows us to determine the car's precise location within its environment. This leads us to the third module known as path planning. Here, we map out the optimal route for the vehicle to follow to reach its destination. Then the last module allows us to execute the route through steering, brakes, and accelerator. The core architecture used by companies like Waymo, Amazon Zoox, Tesla, Cruise, and many others is based on these standard framework. With this standard architecture in mind, let's now explore Tesla's unique adaptation of this framework. Tesla's self-driving architecture introduces 2 key distinctions. First, Tesla merges the perception and localization functions into a unified vision system. This vision system is responsible for both seeing the environment and locating the vehicle within it. The vision system feeds data into the path planning module, which allows it to identify optimal trajectory to reach destination. This data is then fed to the motion control module. This executes the trajectory using steering, accelerator, and brakes. The second novel component of Tesla's FSD system is its vision-only approach. Unlike its earlier models, which used radars and ultrasonic sensors, Tesla now solely relies on cameras and neural networks. This strategic shift was driven by Tesla's belief that the best way to achieve a human-like understanding of the environment, much like how we navigate using our eyes, is through vision alone. Decoding Tesla's FSD begins with understanding its vision architecture. Let's take a closer look at this vision system. The Tesla vision system leverages 8 high-resolution cameras installed around the vehicle to create a fully 360-degree view of the environment. These cameras act like car's eyes and gather data continuously. The challenge that the team ran into is that even though they had 8 cameras around the car, the system only produced flat 2D images. And because of that, it's really hard to figure out the elevation of roads, curbs, or to capture other important details about the car's surroundings. So, to make driving safer, we really need a 3D view of the world around the car. That's where the team decided to add the computer vision techniques powered by artificial neural networks. Using computer vision, Tesla processes these multiple camera feeds on the left through a series of neural networks which combine them into single unified 3D vector space that you see on the right. Think of this as a detailed 3D map that replicates the real world in a way that the car can understand and navigate through with high precision. This 3D vector space allows Tesla's FSD system to see and understand obstacles, pedestrians, and other vehicles as if it's in a virtual simulation of the real world. This detailed view makes driving decisions more accurate, especially in complex environments like city streets. To achieve this, Tesla's engineering team, led by Andrej Karpathy, developed sophisticated neural networks that generate a precise and a cohesive 3D representation of the surroundings, such as this one. This is what the original architecture looks like that was developed by the AI team at Tesla. It's these layers of neural networks that take the camera feeds and do the job of perception and localization. Now let's decode this.
Ashnir Grover, he was able to compete with Paytm and Google Pay, and he positioned
Architecture. Here is the simplified version of this architecture that we'll cover today. Let's break down how this architecture works step by step, starting from the bottom layer of the 8 camera feeds. Tesla uses 8 cameras strategically placed around the vehicle to capture high-definition video streams at 1280 by 960 resolution with 12-bit HDR at 36 frames per second. Now each of these cameras gives a unique perspective, but because of their physical placement on the car, the images they capture are slightly misaligned, as you can see in these tiles. This can distort the 3D view of the system. That's where the calibration layer comes into play. This layer adjusts and corrects those camera feeds so they are properly aligned. It calibrates each camera's outputs, making sure everything lines up correctly. Think of it like adjusting the focus on binoculars so that you get a clear and a singular view. After calibration, the aligned images go through the RegNet layer. This is where deep learning comes in. RegNet is simply a neural network which extracts key features from images, and it does so at multiple scales. Let's take this image of a Tesla to better understand how this process works. On the left, we have the image that's sent to the RegNet layer, and on the right we see what the outcome looks like after the feature extraction process. At a smaller scale, RegNet identifies simple things like color, texture, which is what the lower layers on the right of the neural network focus on. But as we move deep, we can see the upper layers. RegNet here can start to recognize more complex objects like cars or pedestrians. This level of detail across the scale is crucial for the car to understand its surrounding and make precise decisions about how to respond to each of these scenarios. Next is the bidirectional feature pyramid network, or BiFPN layer. This layer takes all the features extracted by RegNet and combines them, helping the system recognize objects at various distances. Think about it like this. If you are driving, you need to spot a car far ahead of us while also being aware of a pedestrian right next to you. The BiFPN layer ensures Tesla can accurately detect and process objects both near and far, giving it a more comprehensive view of the road. Once all the features have been extracted, they are sent to the Fusion layer. This is where the magic happens. The Fusion layer merges the output from all 8 cameras into a single unified 3D model. Here is a quick snapshot of what this looks like. This model is essentially a 3D model which provides a real-time representation of the car's surrounding and is developed by fusing all the data from the camera feeds through the layers that we saw till now. Now that Tesla has a solid 3D model of its surrounding, it's still missing a critical component: time. We still don't know how fast the vehicles ahead of us are moving, and the same applies for the pedestrians, isn't it? That's where the future queue comes into the picture. The feature queue adds a time component by caching data over a period, which lets the system understand how the objects are moving. It's not just about knowing where a car or a pedestrian is, but also understanding how fast they are going and in which direction. For example, take a look at this scene. There are cars in front of us on the side and pedestrians. Wouldn't you want to know their trajectories so you can make a safe move? By tracking objects over time, Tesla can predict their future positions. For example, instead of just seeing where a car is right now at this intersection, Tesla can forecast where that car will be in a few seconds, or even for that matter, pedestrians, enabling smoother and efficient decision making for navigation. Feature queues are great at predicting individual trajectories of each agent in the scene or each pedestrian or car. What about the entire environment or the scene? That's the job of the video module. It's a neural network custom designed to handle this task. Goal here is to understand the entire environment in front of you and the trajectory of all relevant agents in the scene, including cars ahead of us and around us. The video module accomplishes this by combining both the spatial data, that is the feeds from the camera, and temporal data, that is the trajectories of each of these agents, such as cars and pedestrians, using spatial recurrent neural network. This helps Tesla predict how the environment will evolve over time, like whether a car ahead is about to change lanes or if a pedestrian might cross the street, as you can see in this graphic. This data is then fed to Hydras, which is basically a set of custom neural networks, each designed to handle specific tasks on the top, such as object detection, traffic light status check, velocity of adjacent car, and more. Thus, after passing through all these layers, the system produces a coherent 3D model of the environment with predictions of future movements that you can see on the right of the screen. This output is Tesla's combined output of the perception and localization module, also known as the vision system, which allows the car to not only understand where it is, but also predict the trajectories of other objects in the environment. And this essentially is Tesla's vision system. So, the Tesla vision system combines both the perception and localization functions, allowing it to understand surrounding and the trajectories of other agents in the scene along with its own position. Now that Tesla's FSD system has a clear 3D view, it feeds the data into the path planning module. This module uses neural networks to calculate the best route for the car based on its current location, destination, and the environment. The system can predict the paths of other vehicles and determine the safest, most efficient route to follow. Here is a quick demo of the path planner and the motion control module. The path planner evaluates multiple trajectories and finalizes one that is safe, reliable, and legal, further forwarding it to the motion control system which executes it, as you can see out here. Here is another scenario where the Tesla vehicle in red responds to an oncoming car. It looks like impromptu coordination between the vehicles. The navigation system is tuned to adapt to dynamic scenarios like this and respond in a safe and reliable manner. That completes the system architecture of Tesla's full self-driving system. Here is the final system architecture of Tesla designed by the Tesla AI team. This is what we covered in today's case study. The system is constantly evolving. I hope you found this information valuable. For more in-depth coverage of Tesla's FSD system and other self-driving car technologies, check out our full course at boringsh.com. Link is available in the description below. Let me know in the comment section what are the autonomous stacks you would like us to decode in the future episodes.
Now, before going to the session 8, just we will have some 2 to 3 minutes, the fast recap of the 3 days what we have covered in the 6 days online ATAL program. Once again, on behalf of our management, Meenakshi Sundararajan Engineering College, and my own behalf, on behalf of our co-coordinator, Dr. Vijayan, we thank and congratulate the AICTE for considering and selecting our proposal for the 6-day AICTE online ATAL FDP program. The topic is the energy and electric vehicles in India, opportunities, challenges, and future. The inaugural session was given by Professor Dr. R. Velraj, an authority in the field of energy at international level. Also, the professor and former Vice Chancellor of Anna University, Chennai, has given and inaugurated in a nice manner. And we thank you very much, sir. And the second topic is the overseas industries expert, Mr. Ashok Kumar Ellusamy, is currently the Vice President at Tesla USA. He has given the various insights of current landscape of electric vehicles in India, and also as a case study and special reference to Tesla's advancement and what are all the happenings in day-to-day and advancement in Tesla. He has explained through orally and also the videos. And thank you very much, Ashok Kumar sir. Followed by the session 2 is the cost-effective solutions for mass adoption, which was given by the Dr. P. Kumar, the another international expert, also the professor in the Department of Mechanical Engineering, IIT Tripuri, has given very good nice explanation about the cost-effective solutions and also the special reference to the hydrogen production, storage, and implementation, and how this hydrogen energy is going to minimize the cost and will have zero pollution to the atmosphere. He explained with a nice explanation and the case study. Thank you very much, sir. And in his part 2 lecture, in the session 2 is the cooking burner optimization design and how the cooking energy requirement has been reduced to almost 50%, and it has been implemented in a temple nearby Tirupati. That also he has showed as a case study. Thank you very much, Professor. It is a pattern one. I hope the participants across India hope enjoyed that presentation. Now coming to the day 2, that is 28/1/2025 Tuesday, the session 3. The topic is the government policies and incentives for EV adoption. It was handled by Professor Dr. B. Professor of NIT with over vast experience, more than 25 years. Professor Dr. Arumoli Chelvan has explained in a very nice manner how the various government policies are created and implemented and amended, and what are all the various incentives for EV adoption also explained very nicely. I hope the participants in this field will get a real feel of what government feels for this EV adoption. And the same coming to the session 4 again, which was handled by the same professor, Dr. V. Arulmoli Chelvan, professor of NIT, and also the former associate dean, again explained the recent advancement in battery. You all know very well the conventional IC engine is the heart of the vehicle, but for the e-vehicles, batteries are the heart of the vehicle. So he has explained very nicely the various recent advancement in battery, how battery has to be maintained, what is the life of the battery, how it has to be safely disposed to the atmosphere, everything he has addressed. Thank you very much, Professor. Now, yesterday in day 3, the Wednesday, session 5, the heading was the design of electric vehicles, which was handled by Professor Dr. C.G. Saravanan, Professor of Mechanical Engineering and also the Director of Mining Engineering of Annamalai University, Chidambaram. With over his vast experience, he has explained very nicely the various design concepts of e-vehicles, and also he has instituted the IC Engines Laboratory in a very different manner, and also the customized manner to cater the needs of the current and latest trends of research to be carried out in IC engines in Annamalai University. Also, Professor Dr. Saravanan has a vast experience and visiting so many conferences and symposia in so many overseas countries. With his rich experience, he explained very nicely the design concepts of electric vehicle. Then yesterday's last session, coming to session 6, which was handled by Professor Dr. T. Prabhu. He is also the Managing Director, the Energy Solution Limited, Coimbatore. With his vast experience, more than 28 years, he has explained very nicely the renewable energy integration with electric mobility. In spite of his busy schedule, he accepted our invitation and he explained very nicely. Thank you very much, Professor, for the industrial talk on behalf of your Energy Solution Limited for the benefit of the participants. Now, let us move on to the session 8. That is the advancement and impact of electric vehicles on India's energy grid.
All the 3 days about our respected resource person and their deliveries and the valuable speech. Once again, thanks, sir. Now we welcome all our participants for the session number 8. And the same has to be the same resource person going to handle the session, the topic of advancement and impact of electric vehicles in India, on India energy grid. So welcome, sir, Dr. Saravanan, sir, who is going to handle the session number 8. Thank you, sir.
Thank you, Professor, for the welcome note. Is none other than our co-coordinator, Professor Dr. Vijayan, in this ATAL FDP program. Let us move on to the session 8. The topic is the advancement and impact of electric vehicles on India's energy grid. growth of EVs in India. Now, in this topic, what we are going to see means what are all the various advancement in electric vehicles and what's its impact. It impacts particularly in the energy grid of India. In these three categories, we are going to approach this topic. Now, coming to the growth of EVs in India, the government initiatives, already we have seen the FAME 1 and 2 and also the PLI scheme, the state policies. How the EV ecosystem has initiated, has evolved to this category, that is up to 2025. We have seen in the earlier session that policies also we are going to touch a point here. It is a worth note to mention here various initiatives which was given by the state and central government to implement the EVs ecosystem, and that contributes a phenomenal growth in India's EV vehicles, and also it contributes the energy grid of India. Then market trends and adoption rates, key players in Indian EV market. You see, in the year, financial year, it is 16, 17, 18, 19, 20, 21. You see the electric vehicle growth rate, which is number in thousands, that electric vehicles number in thousands, that is 20,000 vehicles and 23,000 vehicles and 54.8 thousand vehicles, 126,000 vehicles, 152,000 vehicles, and in the financial year 21 it is 143.84 thousand vehicles, has been having a tremendous steady and faster growth in India consistently and continuously. Only in the year 2021 it is very less compared to year 20, some 10,000 vehicles are less. Otherwise, it is going in a forward manner, steady and phenomenal growth, accelerating the EV growth in India because of the very good EV ecosystem. This graph shows and reveals that particular data. So we understand that it is contributing the major energy grid for the India. Coming to the India's energy grid, the current scenario, the overview of India's power generation, mainly from the fossil fuels, that is coal and renewable fuels and nuclear energy. These three things are considered, and the challenges in power distribution and load management, that also is going to be addressed. The regional energy consumption trends also going to be discussed. You see the various states of our India, like Andhra Pradesh, Karnataka, Kerala, Tamil Nadu, Telangana, various states of India has been given in this graph, which reveals the scenario of the electric vehicles, how it has been introduced, how it has been a positive, steady growth in a forward inclination manner, which was understood while we are studying the India's energy grid in detail. Coming to the impact of EVs on the energy grid is, it increased the electricity demand. That's why the yesterday speaker also, Dr. C.G. Saravanan, mentioned that even some of the participants also raised more queries. Though we are using e-vehicles, again it depends upon the electricity. So create electricity, again we are depleting the fossil fuels. So it is a closed loop. We have to break that loop. Increase in energy demand has to be decreased by the way of implementing the various fossil fuels usage. To avoid various fossil fuel usage, we have to go for the renewables approach, so that the increased electricity demand has to be minimized, and also we are contributing for the environment. That has been discussed in a detailed manner. Then coming to the load balancing and peak demand concerns, how this electric vehicle is contributing for the load balancing. In the peak demand, how it is addressing that, and also what are all the various impact on the renewables and the energy integration also have to be considered at this juncture. Coming to the challenges of EV integration into the grid, see the charging infrastructure and grid overload risks, variability in charging demand, battery recycling and energy storage. All these three have to be keep it in mind. Coming to the energy storage here. See, this is the finally grid. Starting point is here, the energy source, battery, DC, again it is inverter, storage inverter and PV inverter. Again it is in going to a charging station. Again it is going to the grid, electrical energy. In between we are tapping for charging station. See, vehicles to grid here, here the electric vehicle. EV as a energy storage device. We are, it is a mutual. We are receiving and also giving to the grid when it is excess energy is available with the EV. So this is what the challenges of EV integration into the grid has to be addressed. Now coming to the solutions for a sustainable EV grid integration, smart grids and vehicle to grid, that is V2G technology. It is called as V2G technology. That is vehicle to grid technology. Then renewable energy powered charging stations. Then energy storage solutions, battery swapping and grid batteries. So this diagram is and you see the photovoltaic farm is here, and from there it is going to the smart grid. Again, it is a renewable one. It is renewable energy is used the solar energy. Now coming to the wind energy is being used from the wind farm, and thermal power plant also giving. So these three energies going to the smart grid, and also from the nuclear power plant we are getting energy. All these things in the two-way polarity or two-way connection has been given to the electrical vehicles. Here, from the smart grid, it is going to the various offices, it is going to the various homes for domestic purpose, and also it is going to the various industrial companies. This is what the various solutions for the EV grid integration, because already a conventional grid is there and the electric vehicle grid is there. How it has to be 100% or near to 100% to be sustainable in nature, to be using the renewables. These are all the various contributions, that is PV farm and wind farm and the thermal power plant. Again, you all know that thermal power plant, again we are depleting the fossil fuels. So all these things have to be addressed and has to be used these technologies in a optimized and adjustable manner, so that in order to get the maximum output of the renewable energy and also to little bit from the fossil fuels. Then coming to the government policies and future roadmap, the national and the state level EV policies is there. Central government is also implementing one policies. State level also EV policies are there. It is up to the EV ecosystem or the EV startup persons to read carefully, to understand carefully, and to adhere carefully. Then only we can success in the EV market. So we should be very thorough with the national and state level EV policies. And coming to the renewable energy integration with EV infrastructure, again it is a quite new area. The young researchers or new researchers, already those who are in the research field can take up this, the integration of EV infrastructure with the available renewable energy, so that it is sustainable in nature, it is not degrading the environment. So this area is getting a momentum now, and this renewable energy integration should be done with the EV infrastructure, so that we will have the fossil fuels depletion decrease momentum. We can see that. Then future roadmap for the sustainable energy and transport also have to be addressed. Some case studies in global best practices has to be known. For want of time, we are not showing that case studies. Lessons from countries like Norway, China, and the USA are much ahead for using this integration of earlier they are using basically with the in hybrid system vehicle drivability using the battery in cities, outside cities using the fossil fuels, in the conventional IC engines, that is called hybrid technology, and also charging of EV system using the renewables. These countries are contributing well in terms of research, novelty, innovation, and implementation. And also a lot of startups are there in Norway, in China, and in USA. So I request the participants during your free times, please look into these case studies and global best practices so that it will pave the way for us to further to serve our mother India to have the self-sustained one in terms of EV ecosystem. Successful Indian pilot projects are also there and very good initiatives are also there. These initiatives, the new and young researchers should keep it in mind and also go through it, also to visit those uh, uh, pilot projects in person physically and to have a thorough study on that, and while integrating the renewable energy with that the available EV grid has to be taken into account and it has to be used in a more efficient and effective manner. The debate over the electric vehicles in India is a complex one. It involving the various considerations of emissions, cost, and policy. While EVs are often touted as a zero emission vehicles, experts pointed out that in India, where 75% of the electricity comes from the coal, that is fossil fuels, the life cycle emissions of EV may actually be higher than those of the internal combustion engines vehicles or the hybrid in some cases, because it is a debatable one. While battery technology has come into effect, instead of polluting the atmosphere in the vehicle, we are polluting the atmosphere while charging the battery. And during discharging of battery, also due to chemical reaction, some amount of pollution are liberated to the atmosphere. So all these things are taken into consideration. It is a debatable one. It is a researchable one. Now the country or the R&D is going in the direction how the battery materials can be replaced, sustainable one, efficient one, powerful one. The direction is going in that positive way so that the debates will come to a comma or full stop. We will be successful one in future in the years to come. Coming to the electric vehicles, the advantages and challenges are there. There can be no denying that the era of electric vehicles is well and truly upon us. With zero tailpipe emissions, EVs are a direct cure for the air pollution and will also helpful reduce oil imports. See, I am slightly differ from this because the thing is, in order to have the sustainable environment, low pollution environment or zero pollution environment, we are moving from conventional IC engine powered vehicle to the electric powered vehicle. But this cannot be taken place overnight. The already vehicle available in India run by IC engines with either the diesel fuel or petrol fuel has to do an after treatment process, because EVs are direct cure for air pollution, but IC engines are emit a lot of NOx into the atmosphere that will affect the environment. So I request all the researchers and the participants in this group to take into account. We have to do two types of, or rather than 3 or 4 types of treatment for the already available conventional IC engines that run in Indian roads in millions of vehicles in every day. One thing we can do that the using the alternate fuel technology, using hydrogen fuels, it will reduce tailpipe emissions, and also the converting the heterogeneous combustion into the homogeneous combustion. For that, the thorough mixing of both fuel and air are needed, and also the conducive in nature temperature inside the engine cylinders are required. Because we all know that diesel vehicles are more. Heavy vehicles are in India, the concept is only diesel vehicles, either 4-cylinder or 6 cylinders or 18 cylinders, like that it goes. So the diesel fuels self-ignition temperature is very, very less compared to the petrol fuel. Normally, the gasoline will have the SIT of 650 degrees centigrade. That's why we are having an external energy called spark plug. But coming to the diesel engine, it is a self-ignite temperature is very, very less. That's why we are not having any spark plug in diesel engine, only fuel injector. If the fuel is injected in the compressed air, the air which was sucked during the suction stroke, and it is getting compressed, we all know very well that the entire air which was sucked during the suction stroke of the diesel engine, its pressure and temperature is very less during the first stroke. After the second stroke, pressure is increasing, pressure and temperature are directly proportional. If pressure increasing because of the reduced volume, temperature is also increasing. So before the injection of the diesel fuel, the situation or the atmosphere inside the engine cylinder is the atmospheric air with high pressure and high temperature. When the diesel fuel is injected because of the SIT, self-ignition, very less for diesel vehicles, high-speed diesel oils compared to the gasoline oils. These will have a temperature of 350 to 450 degrees centigrade. The combustion takes place. Here, an important point, combustion dynamics and combustion simulation studies has to be done, and we have to convert the combustion taking place at multiple sites to be converted into heterogeneous into homogeneous. That will reduce tailpipe emissions. That is second approach. First approach is alternative fuels. Second approach is studying the combustion phenomena and converging into the less tailpipe emissions. Third approach is the tailpipe emission. Before going to address this tailpipe emission, we have to address the after treatment technologies. We have to do a retrofit type of kit, or before going to allow the exhaust gas to atmosphere, it has to be treated well. That is, this NOx has to be reduced and to send out to the atmosphere. This is called, after the combustion, the treatment is being done, so it is called after treatment technology. So that we have to do it by following all these three things. That is, by using alternative fuels, by using the more advanced and optimized combustion technologies, and also to have the after treatment technologies, we can reduce the tailpipe emissions that are coming every day, 24/7 into 365 days, that runs in India, millions and millions of vehicles that runs in our Indian roads. This problem has to be addressed first. Let it go in a concurrent way, in a parallel way. Let it go the conversion of IC engines into EV. Let it go in one side of the coin. Other side, we will take care of the tailpipe emissions, which is already available in the market, which is already running in Indian roads, has to be addressed by these three technologies, as I mentioned: alternative, optimized combustion technology, and after treatment technology. That will give more and sensible result for our mother India, for our mother nature, to take care of that, to reduce the air pollution. Let it be have the reduced the tailpipe emission from the old conventional IC engines, and also let us have the EV vehicles contributes for the cure for very good less air pollution or zero air pollution, so that we will have a very good air to have better breathe and to avoid lungs problem in the human being, and as well as for the animals, and as well as for the plants. So this will have very good impact. Please address all these issues. Then there has been a significant rise in the production and sales of electric vehicles in the recent years. Many major automobile manufacturers have invested heavily in EV technology, launching a wide range of electric models to cater the growing demand. This increased availability and diversity of electric vehicles contribute the nation that the era of EV is indeed the underway. So we have to contribute in a nice manner to take care of our mother nature. Advancement in battery technology and the infrastructure have played a crucial role in accelerating the adoption of EVs. The development of more efficient and affordable batteries has extended the driving range of electric vehicles, reducing the range for anxiety for customers. Additionally, the expansion of charging infrastructure, including the public charging stations and home charging stations solutions, has improved the convenience and accessibility for EVs for drivers. Furthermore, the governments and policy makers around the world have shown a strong and commitment to promoting the electric vehicles as a means to address the climate change and reduce emissions. Before going to the next topic, I request the audience, since it should not be a monologue one, do you have any clarification or any doubt? I'm very happy to address on that. Then we will move on to the next topic. Beloved audience, do you have any clarifications, any doubts, or any points you want to be given stress for that? Participants? Participants, please speak louder, please. என்னோட சிஸ்டத்துல வால்யூம் கொடுங்க. இதுல சுரேஷ் குறைச்சிருக்காரு நினைக்கிறேன். Participants, your voice is not audible. Dear participants, is it audible? All are in online?
Yes, sir. Is it audible, sir?
Yes, sir,
You are
it's
in
audible.
online. There's no response from you. I don't know whether you are in online, whether audio and video or screen sharing is live or not. Okay, if there is no queries, shall we move on to the next session, next section?
Yes, sir. Yes, sir.
Yes, sir, yes, sir.
Fine, fine. Thank you. Thank
Sir,
you.
no audible, sir.
Not audible.
Can't
It's
hear
audible.
your voice, sir. I think something error.
Is it clear now?
Yes, sir.
Yes, sir.
It's audible
Yes,
only.
Yes, audible, sir.
Okay, madam. Thank you. Thank you, sir.
चलो सब लोग मिलकर आमरस पीते हैं। हाँ, चलो हम लोग बनाते हैं। अरे आमरस रेडी है और क्या चला
Okay, let us move on to the next section. Why are EVs are crucial? The environmental benefits. EVs have the potential to significantly reduce the greenhouse gas emissions and combat the climate change. This we all know very well. Since we are all faculties of engineering college, I no need to give the in-depth details of GHG, that is greenhouse gas emissions and combat climate change. Unlike fossil fuels, that is conventional fuel technology, that is diesel and fuel engine vehicles, EV produces zero tailpipe emissions. We have witnessed in the last section. EVs help to reduce the carbon dioxide and other pollutants that contribute to air pollution, smoke, and global warming. Fog plus smoke will give the smoke, you know very well. The New Delhi problem in the way back 2000, the newborn child are continuously facing breathing problems because of the lung has been disturbed a lot because of the exhaust gases. Then doctors and researchers found that the environment has been deteriorated a lot, the air has polluted a lot. That's why in the NCR region, fossil fuel vehicles has been fully eradicated. Now we have only CNG vehicles in the 30-kilometer radius and 50-kilometer radius. It has been introduced in a phased manner in our capital of our mother India. That is again another case study. It will take half an hour to explain. I request the participants, please log on to the website and to get to know what is what, why this word smoke comes. And also it is contributing for the global warming. The electrical vehicles that help to reduce the harmful pollutants such as nitrogen oxides, we shortly call it as NOx, particulate matter, that is PM, and volatile organic components, VOCs. This has a direct positive impact on public health, as a cleaner air reduces the risk of respiratory and cardiovascular diseases, as I mentioned earlier. Energy diversity and security. E-vehicles contribute to the energy diversity by reducing the dependence on oil imports, as the electricity grid can be powered by a mix of energy sources, including the renewables like solar, wind, and EVs offer the opportunity to shift the transportation towards the cleaner and more sustainable energy options. This reduces the vulnerability of fluctuations in oil prices and enhances energy security by reducing the reliance of the fossil fuel imports. Technological advancement and job creation. EVs will have this kind of positive approach. The development and adoption of the EVs have the super read the technological advancement in battery technology, electrical drivetrains, and also the charging infrastructures. These advancements are not only the benefit to the automotive sector, but also have the broader applications such as energy storage for renewable energy sources and grid stability. Electrical mobility creates job and innovation in battery manufacturing, renewable energy, and charging infrastructure. Next is the long-term cost savings. Electrical vehicles have the lower operating costs, as the electricity is generally cheaper than the gasoline or diesel. Moreover, EVs have the fewer moving parts and requires less maintenance, resulting in reducing servicing and repairs expenses over the time. At this juncture, I just want to tell an important case study which I have guided in a particular project leading to PhD of Anna University, Chennai. So we did a VAM, that is vertical axis windmill. These windmills has been installed in the highways, and since it is a vertical axis, either side of the vehicle going forward and return direction, the VAM, the vertical axis windmill, have the clockwise rotation. And also on the top of the VAM, we have incorporated the solar panel, so that the output may be very, very small, very, very minimal one, but it contributes a lot when an array of a galaxy of these vertical axis windmill powered with the that means incorporated with the solar panels give very good electricity, and these electricities we no need to transport or storage somewhere else. These electricities are used then and there in the traffic light signals. So in that area is another important area, the photovoltaic material, what are all the latest material, how we can have with the small area of solar panel will have the larger electricity, and how to optimize the vertical axis windmill blade shape, direction, material, thickness. All these things have to be addressed, and again it is the further scope for research area. And the silicon material which is used in the solar panel also is another area, how to minimize the cost and maximize the efficiency. As you all know very well, it has to be faced south, and it should have the 30 to 45 degrees from the top to lower, and we have the maximum solar energy coverage from morning 11 a.m. to 2 p.m. All these things are there. So in that vertical axis windmill, which was solar panel, which was embedded on the top of the van, that we have followed all these directions, and fixed solar panel also there and movable solar panel also there, in order to have the maximum thing. And these energies are used in night times then and there for the traffic lights, as I told earlier, and the daytime it will have the minimum cost storage device, which will be stored in the plant, power producing site itself. All these things can be used in a very nice manner and in a adaptable manner, and based on the requirements, based on the situation, we can convert our needs and approaches and usage. Yes, research, there is no end for that. Coming to the decongesting the cities, electrical vehicles can help the decongesting cities by promoting the shared mobility and compact design. Shared mobility refers to the use of vehicles as a service rather than as a personal asset. Because in our India only we can see that for one person we are using the 5-seater car. Again, it costs more traffic. This can reduce the number of vehicles on the road and the need for parking space. In foreign countries and all, for example, you take a sample at UK. If you are not parked the vehicle in a proper manner, in a proper place, you have fine immediately. So that's why people are motivated to use the public facility like buses and electrical trains. And moreover, countries like Netherlands, they're encouraging the cycle is being used for the nearest place, going purpose and market going place, playground and going to school, going to office, like that. So all these approaches, I'm telling again and again, will contribute for the mother nature, for the less air pollution, and we are to our level in a small way we are contributing. So all these best practices which is being followed throughout the world, we have to witness and we have to follow the same. Compact design refers to the use of smaller and lighter vehicles that can fit more easily in urban spaces. This can also reduce congestion and emissions. Innovative and futuristic smart EVs for shorter intra-cities distances, day trips, and the same light would not be a need a bigger battery. That means less time to recharge and lower cost, and their area of transportation, area of usage within the city limit. So within the city limit, naturally we will have more charging stations. So if any breakdown also happens, there are people to address the gathering. All these things we have to keep it in mind. Coming to what are all the challenges for EVs, high initial cost, as we know, and for past 3 days also all the session speakers are telling the same thing. Initial cost is very, very high. Normal people cannot afford this. Only the middle level people and lower level people cannot afford this initial cost. Only the higher people can afford this. The upfront cost for purchasing the electric vehicles is relatively higher compared to the conventional vehicles. The higher initial cost makes it less affordable for many potential buyers, limiting the demand for EVs. That's why, like IC engine powered vehicle, the demand or interest, as I told, the ADA principle for purchasing, it is not that much momentum in India at present, but in future it will have more pickup, because we have the various stringent emission laws and by the central government and state government, vehicles like 15 years old will be given the further permission only for 5 years. After 5 years, it has to be condemned or some cost has been given by the government. For example, a 15 lakhs car which has been used for 15 years or 20 years, government some formula, some ratio is there on pro rata basis. Due to the 20 years of depreciation, government is giving some 1 lakh. So 20 lakhs is become after 20 years 1 lakh, and having this as an initial cost, we can buy for the new e-vehicles. Though the cost is more, but the environmental pollution is not very, very less. It is near zero. It is almost zero. It is zero. So we have to have this approach for our health benefits to contribute for the mother nature and also to follow the government legislative and government directions. That's why in more population countries like India, we are not implementing at a stage. We are implementing in a phased manner. In metropolitan cities first, and the second level of cities, and third level of cities, and final our target is the urban and the villages. We have to have that type of approach. Then another approach is there. If the manufacturer are manufacturing in more numbers, huge quantities, the EV charge may come down. That is also there. That approach is also being done. And we are importing lot of parts of the EV vehicles. And if we manufacture in our indigenous only, in-house one, again its cost will come down. Like that, lot of factors are there. Then limited charging infrastructure, as we already addressed this. Now we do have 4 charging stations in highways and even in rural areas also. In India, the charging infrastructure is still in the early stages of development and it is concentrated in major cities. Now it is picking up in a positive way. The lack of a robust and widespread charging network makes it convenient for EV owners, especially for those living in apartments or without dedicated parking space. This is another area to be addressed. Then range anxiety. The range anxiety refers to the fear or concern of running out of battery charge while driving. Then limited range is a significant challenge for EV adoption. At this point, I just want to tell one important case study. Again, I'm just telling you only the 2 to 3 lines of that case study. Suppose we are using the e-vehicles for ambulance purpose. Suddenly, the battery gas discharged. What is the condition of the patient? So this fear or concern is there for the common public, in public mind, that if my e-vehicle battery has running out of charge or battery has been discharged, what to do? To avoid that, in the earlier phased manner, we should have the hybrid vehicle, both EV and as well as the conventional IC engine. We call it as hybrid vehicle. This fear or concern can be reduced or minimized. This one could be the possible viable solution, technically feasible, economically viable solution for this range anxiety. Another point, although EV ranges have been improving, there is a still perception that EVs may not offer significant range for long distance travel, particularly in a country with vast distances like India. The batteries in EV degrade over time, which can lead a decrease in range. Even I do have a personal experience of driving a two-wheeler e-vehicle. That vehicle in the normal latitude or the normal ground, it is going in with good speed and torque. But while taking a turn, or if more road is there, or in the place where peaks, valleys, no problem. When a peak is there, at times, sometimes it is not satisfying our requirement, there comes the fear or concern. But at that point, when the two-wheeler is driven with petrol or diesel, it will give very good output. But I'm not against EV, but this thing is there. But these things will be overcome with the very good battery capacity and battery material. Again, if you go for very good battery capacity and very good battery and very good branded vehicles, that costs more. That more cost is not affordable by the average and normal people life. These are all the things we have to address and we have to research further to cater the needs of the common publics, the fear or concern, anxiety in the field of e-vehicles market, R&D, production, innovation, and to satisfy the people's day-to-day requirements in terms of transportation. Coming to the battery technology and supply chain, the production of lithium-ion batteries, which are a key component of EVs, requires specific minerals, rare earth elements is being used. India currently relies heavily on imports of battery manufacturing, leading to supply chain challenges. The charging time of EV is longer than the refilling time of a conventional vehicle, which affects their convenience and usability. Time is the major problem, because if I want to recharge with a normal conventional IC engine, either with a diesel or petrol, it is few minutes. If it's less, it few seconds. I can recharge half liter or 1 liter. I can go the two-wheeler. But it come to the case of EV, charger time is more longer. If I want to reduce the charging time is less, I have to invest more. My battery should have that capacity. My charger should have that capacity. Again, if more capacity of charging in less time, I prefer, I have to pay more. All these things are there. Limited model options also there. That is currently the availability of electric vehicles models in India is relatively limited compared to conventional vehicles. The market needs more options in various segments, including affordable EVs, to cater the diverse consumer preferences and requirements. See, at this point, I want to tell one very good initiative of our state and central governments. To some capacity of two-wheeler, they no need to have the RTO registration also. Simply like cycle, we can get the two-wheeler, charge it and use it. It is there. It is there in RTO document itself. All these things are not reaching to the down the line to the rarest place of village. Only in urban side, people are very aware. The uneducated peoples or less educated people should know this first. For a minimal small size investment, a mini size two-wheeler without any RTO registrations, we can buy and we can use it. So these are all the things we have to appreciate our government in terms of initiatives, in terms of for RTO registration amount is reduced for the common public. So all these things we have to make them known to the last end, frag end people of any Indian and every Indian, and it is our fundamental duty to take this message to that level. 1 second, there is a chat message. Okay, audience, please wait. The feedback form will be given to you by sharp 9. Don't worry. Okay. As we already touched this point, some argue that hybrid vehicles with their smaller battery packs and improved fuel efficiency may currently offer a better balance of emissions reduction and cost effectiveness to the Indian context. We already discussed in detail. The debate also touches on the role of government subsidies and policies in shaping the automotive market. Looking ahead, the future of EVs in India appears promising, with increasing adoption in two-wheeler and three-wheeler segments, ongoing improvements in battery technology, and the government push for cleaner transportation also there. What are electric vehicles? Electric vehicles are the type of vehicles that use one or more electric motors for propulsion purpose instead of your traditional internal combustion engines that burns gasoline or diesel. Through the concept of electric vehicles has been around for a long time, it has drawn a considerable amount of interest in the past decade, aimed in raising carbon footprint and other environmental impacts of fuel-based vehicles. See, the carbon footprint is another very interesting area that will take more time if I touch upon that point. what are all the carbon footprint of each and every countries contributed to the overall world map. We should have the reduced footprint. All these things are in account. And various type of electric vehicles are battery electric vehicles, solely rely on the battery power, and the plug-in is combined in an electric motor with a gasoline engine, like it is called plug-in hybrid electric vehicles. They can be charged externally and run on battery power for a limited range, then switch to the gasoline engine for longer journeys. Hybrid electric vehicles use both for electric motor and also the gasoline engine, but for the battery cannot be charged directly by plugged in. The battery charge by the gasoline engine through the regenerative braking system also possible. Benefits of EVs: reduced emissions, produce zero tailpipe emissions, contributing to the cleaner air and improved public health. We have touched this point so many times today, yesterday, and day before yesterday, and also the first day of the reopen of the in the inaugural letters of our Honorable former Vice Chancellor Dr. Velraj are also touched this point. It is the major thing we have to keep it in mind. Lower operating costs. Electricity can be cheaper than gasoline, leading to lower fuel costs per kilometer, quicker operation, improved efficiency. And why in news? Recently, HSBC Global Research has released a note suggesting that in the next 5 to 10 years, India should promising adopting the hybrid electric vehicles as sustainable mobility solution before transitioning the full battery electric vehicles in India. Hybrid electrical vehicles integrate a conventional IC engine with an electric propulsion system. How India faring the in adopting e-vehicle technologies? India is actively pursuing the electrification in the automotive sector with the significant investment and focus on EVs. While many automobile industries in the country are heavily investing on EVs, some are prioritizing the hybrid vehicles. The government is providing the clear tax incentives primarily for a specific category of cars. Other technological platforms in the automotive industry are grouped together in the upper end of the tax bracket, suggesting a tax structure that may not be equally favorable for all types of vehicular technologies. Countries like India, electrical mobility plan is prominently focused on the widespread adoption of uh, electric vehicles to replace the traditional internal combustion engines vehicles. In this context, lithium-ion batteries are currently considered the most viable option for this. This indicates a strategic emphasis on the battery electrical vehicles and the performance for the specific battery technologies to drive the electric mobility transition in our country. What are the battery electric vehicles? Battery electrical vehicles are the type of electrical vehicles that runs solely on the electrical power. This already we have seen. Lithium-ion batteries are higher energy densities, longer range, improved performance, charging infrastructure. Battery electric vehicles requires a network of charging stations for recharging their batteries. Charging infrastructure includes the various types, level 1, household outlets, level 2, the dedicated charging stations, level 3, DC fast chargers. Public charging stations, workplaces, and the residential buildings play a critical role in expanding the charging infrastructure. Then EV policies, already we have seen in the second day of lecture. For want of time, I'm skipping this. Just one or two important points I will touch. The incentivizes the EVs through a rupees 95 crore scheme by the Ministry of New and Renewable Energy, that is MNRE, offering up to 20% incentives on ex-factory prices withdrawn in March 2012. And National Electric Mobility, NENP, all these things, the FAME, everything has been addressed by Dr. Arupul Chelvan, the professor of NIT in the second day. So I'm skipping this. Now coming to the EV India policy roadmap, 2010, what was there, 2012, 2013, 2015, FAME Scheme 1, FAME T Scheme 2, all these things already we have seen. So I'm skipping this. What are the environmental benefit while using the EV adoption? Put it in a nutshell. I'm telling three things. We will have cleaner air. We are contributing the mother nation, and we can have the better environmental better health for human being, the animals, and also for the plant. What are the major challenges related to electric vehicle adoption? High cost, all these things we have discussed. Then electric vehicles in India, various challenges, 12 challenges we have discussed, and extra challenges also we have discussed, coming to the dual X price, power crisis, charging infrastructure, digital and economic divide, e-waste management, and changing the fuel dependence. All these things we have already addressed. Lack of robust local battery manufacturing ecosystem in India heavily relies on the imported lithium-ion battery. And the last point, the skill gap in EV maintenance. For that, the so-called Ministry of Non-Conventional Energy Resources and the Skill India program, various skill gap has been reduced by our Honorable Prime Minister of India, Narendra Modi ji, because of the rural upliftment, and with less cost, skilling is being done for the EV installation, EV maintenance, and EV skilling programs. A lot of things are there throughout the India, and through various NMRE scheme also it is being suited up in school level, polytechnic level, and engineering college level, and university level. Our central government of India is promoting various schemes to reduce the skill gap of EV ecosystem. Thanks to our Prime Minister for taking very good positive initiatives to cater the needs of the our today, and also on par with the international standard. Our India is also flying high with the help of the reducing skill gap and more EV ecosystem. Now, apprehensions on the adoption of the Indian conditions. India's extreme temperatures in summers offering exceeding more than 40 degrees in many regions can significantly impact the performance of electrical vehicles, and also the EV can facing the problems in cold regions. All these things we have touched the point earlier. What are all the measures can be adopted to accelerate the EV adoption? Battery lease to own program, and also the battery technology improves, lessors can upgrade the newer models and reduce the cost. At the end of the lease term, users can buy out of the battery or return it for recycling. Yes, it is a valid point. This could reduce the initial EV cost up to 40%, making them more competitive with internal combustion engine vehicles. Invest in battery technology. Current batteries are small and have the low voltage capacities, limiting their availability to enhance the EV propulsion and extend the travel distances. To tackle this issue, the private companies need to innovate by developing the batteries made through the lighter weight materials with higher energy density and capable of being charged using renewable sources. EV Rural Entrepreneurs Program, as I already told, and implementation of mobile app for users for locate and book these, and more income from charging stations. Highway battery swap corridors are there, and parenting with the Daba owners host these stations for providing additional income. Creating an online reservation system for swap slots are there to minimize and wait in times of during the peak travel. Then equal subsidies to EVs and hybrids. Government should consider the EVs and hybrid equally for subsidies in both technologies, offer significant environmental benefits. That is also picking up. Policies should be dynamic and adapt for developing the landscape, focusing on life cycle emissions and autos, the total cost of ownership. This is also there. All these things will finally electronic waste create new economic opportunities and promote circular EV ecosystem. When can India learn from other countries' success? Europe, that is EFTA, UK, financial incentives. Key takeaways in India are the continued support through the financial incentives significantly to boost EV system. Various case studies are there in China. Lessons from India. While India offers government support, its demonstrate EV market lacks the same level of competition. Encouraging the competition and continued government support can lead through the Indian EV industry. A lot of things are there, but people are not interestingly reading that and following that and getting benefit out of that. That we have to motivate that. And that's all from my side in this session. Second session, any questions? I'm very happy to clarify. Sorry, vote of thanks. Sir,
Yes. Yes, Thanks, Dr. S.V. Saravanan, sir, who is taking for the past 3 hours from 6 o'clock to 9 o'clock. It shows your in-depth knowledge in the about the title, these two titles, both the one of us two sessions he handled, which is very useful for the participant as well as a coordinator for me also. Almost all the participants will get benefited from this valuable and informative speech. Thank you, our coordinator, Dr. S.V. Saravanan, sir. And from participant side, if you have any doubts, please raise your doubts. Our professor is ready to clarify all those doubts. Please.
If there are no queries from participant side, thank you very much, Professor Dr. Vijayan sir, and also my co-coordinator of this 6-day ATAL online activity program for your vote of thanks. Thank you very much. Good night to all of you. The feedback link is shared in the chat box. Kindly fill it that. Again, we will meet tomorrow by 5:45 p.m. Thank you. Chat box the name. வீடியோ எடுத்து போட்டோ எடுத்து அவர் நிறைய கஷ்டப்பட்டிருக்காரு மாதிரி நான் ஒரு ஆங்கிள் கஷ்டப்பட்டிருக்கேன் அவர் ஒரு ஆங்கிள் கஷ்டப்பட்டிருக்கேன் நான் எப்பவுமே ஈக்குவல் ரெஸ்பான்சிபிலிட்டி
அவரு ப்ளீஸ் கிளீன் போட்டுருங்க.
டைப் பண்ணிருக்கோம் ப்ளீஸ் கிளீன் வருது சார் ஓப்பன் ஆகுது. ஓகே இல்ல மியூட் பண்ணிட்டீங்களா? பேசுறது கேட்கணும், ரெக்கார்ட் ஆயிடுச்சு. ரெக்கார்ட் ஆயிடுச்சுக்கா? க்ளோஸ் பண்ணிருக்கோம். நீங்க யாராவது சொல்றாங்களான்னு பார்க்கல.